Good morning, everybody, and welcome to day 2 of the Delta session of the Nearshore Restoration Summit and Synthesis. We are so glad to have you, and we had a really great day yesterday, and we're excited to continue that momentum today. My name is 𝗏𝘃 and I'm the Science Manager for the Estuary and Salmon Restoration Program at the Washington Department of Fish and Wildlife. And I'm also the chair of the Puget Sound Ecosystem Monitoring Program's Nearshore Work Group. Before we get started today, I would like to acknowledge that we are gathered together but apart on Coast Salish ancestral homelands. I am speaking from Olympia, Washington, which occupies the traditional territories of the 𝗂𝗏 𝗏𝗂𝗃 and 𝗂𝗏𝗃 peoples, whose ancestors resided here from time immemorial and who still thrive today. We respect and uphold the Coast Salish peoples and sovereign tribal nations as knowing bodies and defining partners in our effort to improve the integrity and resilience of ecosystem processes that support environmental and human health and well-being. Welcome, everyone. As we gather in this virtual space, I would like to orient everyone to our Zoom rules of the road for this summit. First, settle in. Get your coffee or your tea, enjoy yourself. This is going to be really fun, and we just invite everyone to really get comfortable. Second, if you can, if you're able, give yourself permission, a little present of unplugging from all of the other things. So flip over your phone, push it like to the other side of your desk. Close your email and let yourself engage with this really awesome material and these wonderful speakers that are going to be presenting today. Ask questions. There's a lot going on. So if you can, give yourself that permission. So if you're having a technical issue, that is the place to tell us about that. Or if you want to reach out to a summit organizer, is the chat. So you'll have a chat function for that. If you, that said, if you're a panelist, either today, and that means a speaker in Zoom webinar lingo, if you're a panelist, you can't use the chat, so you can't use the question answer function, so you have to use the chat to ask a question of another speaker. But attendees, if you have a question for a speaker, the best way to get that answered is to use the Q&A function and to write the speaker's name to who the question is addressed. And then we will be answering some questions live, of course, after everyone speaks. But speakers, if you're able to monitor that Q&A, and our team will be helping you to do that, sort of pointing you to where there are questions. We would love to have you answer those in writing if possible. And then our team, again, will be really helping to triage that. So if you're speaking, you don't need to worry about tracking it to answer at the end of your talk. We'll be reading them to you in that time after the Q&A. Speakers, please don't forget to mute yourselves when you're not speaking and have your video turned off when you're not speaking. So our moderator, who today will be Jason Toff from the University of Washington, he will unmute and say 2 minutes left at 10 minutes into your talk. So that's, you'll get a little warning. And then at 12 minutes, Jason will unmute and play an alarm and turn his video on. And we really encourage you at that moment to wrap up your talk. We want to allow for time for some interaction and questions with the attendees. So when you see that cue from Jason, that means like put a little pin in it, and remember that we have the proceedings that we'll be generating from this effort, where all of the speakers will be able to expound in all the detail they want about the material being covered. So we will have a break in the middle of the morning, and this will be an opportunity for attendees and speakers to informally interact. And this is using something called Wonder, and we'll explain a little bit more about that when it's right time for the break, but just know that there will be a space for everyone to sort of interact and chat with one another in a way that's not orchestrated or facilitated. by the summit organizers. So you'll just kind of get to have some fun. So we have invited a group of scientists and practitioners here today for the summit that represent an interdisciplinary set of perspectives. And our collective job is to create a space that is respectful and open. And we ask for everyone's help in creating that space. So huge thanks to our steering committee. This amazing group of people really helped us to define the questions for the summit and to create a vision for the structure and makeup of the summit that you see. We thank 𝗏𝗏𝗏, Megan Detier, Jennifer Griffiths, Devin Smith, Chris Ellings, Simone DesRoches, Doris Small, Sydney Fishman, Dawn Pucci, and Paul Cheragino. Thank you all so much. And then I'd like to introduce our summit planning team. We are here today thanks to the hard work of this entire group, and we are all here helping to make sure everything runs smoothly behind the scenes today. So I'd like to just introduce Lindsay Desmond, Jenna Jewett, Darren Williams, Hannah Faulkner, myself and my cat, David Trimbach, Jay Kreenitz, and Jason Toft, who will be your moderator today. So just to orient you a little bit to where we are sort of in the summit trajectory, because it's a 3-week effort. Last week, we had 2 days focused on beach ecosystems. Today is day 2 of the deltas. And then next week will be embayments, and come back for that because it's going to be good. So this is we're just really excited to have all of this. And then I just feel so humbled and inspired by the expertise, perspectives, and knowledge encompassed by the amazing speakers that we have today. We've got 78 individuals from over 50 organizations. And by today, I mean the entire summit, obviously, from state, local, regional, federal, tribal, nonprofit, private, academic. So a real array of entities and institutions who will be presenting their perspectives today. And I encourage everyone to browse the program and read their full biographies. So these speakers were each of them was individually invited to reflect contributions from natural scientists, from restoration practitioners and planners, and social scientists, including diversity, equity, and inclusion experts, to help us think about how we can better incorporate these principles into our restoration work. So how did we get here? The idea for the summit really started from conversations between the Puget Sound Partnership's PSEMP Nearshore Work Group, led by Jason Toft and myself, and the Washington Department of Fish and Wildlife's Estuary and Salmon Restoration Program led by Jay Kreenitz. And we just started talking, and everyone that we sort of floated the idea to over the last couple years has been really supportive. We started talking to David Trimbach, and he really helped us to think about how we can bring social science into this effort. And of course, we thank PSEMP for the funding to help make this happen. So what are our goals? We developed these goals with the help of the steering committee. And so first, we wanted to synthesize the nearshore restoration science, focus on Puget Sound for the last 10 years or so. We wanted to capture these important insights from restoration practice. And then we would like to identify the most important science and management questions that will guide future restoration actions. And then we wanted to update the Puget Sound Nearshore Ecosystem Restoration Project conceptual models for how we think about a restoration action and the ecosystem responses to that action, to those actions. And then we wanted to look at those models and also think about how we might incorporate social science principles, including diversity, equity, and inclusion. So these were sort of our overarching goals for the summit. And so to get at this, we posed a different set of questions for each kind of speaker. So we addressed each group of speakers with a different set of sort of over-organizing questions to help them to help guide their presentations. So for natural scientists, we asked, what are the key implications of your research for planning or implementing process-based restoration? For you, what are the most important uncertainties to address with future research that will result in more effective restoration? And then how does your work, if it does, improve upon or inform the 𝗶 conceptual models for restoration? So if there's a connection, we just wanted to capture that. For social scientists, we asked, what does your social science field, area of expertise, et cetera, contribute or add value to planning or restoration? What are the major social science gaps and needs that you observe or experience within your field or area? And then what needs to be done for you and your research to be better integrated into practitioners or natural science researchers' work? For restoration practitioners and planners, we asked, what have you learned through your experience with project development, design, and implementation that informs the needs of future restoration? And for you, what are the most important scientific uncertainties, be they natural or social, that limit planning, designing, implementing, or evaluating nearshore restoration? So what you see today is a blend of all of these disciplines that will be speaking, when we really tried to give everyone equal airtime. And I am going to just skip the rest of my introduction because we need to pass the mic to Jason Toft, the moderator, and our first speaker. So
I'm even giving Tish the hook here. So
I'm giving myself the hook. Yeah.
Great introduction, Tish. Thank you very much. And 𝗂𝗃𝗄𝗵, if you are out there, which I see your name, if you could start sharing your screen, please.
Yes.
While she's doing that, I'm Jason Toft at UW, as Tish said, and we're super excited today. Katrina is sharing her screen. So she's with Western Washington University and will be speaking today about sediment accretion in the 𝗃𝗏𝗄𝗆 River estuary. Take it away, Katrina. Your slides look great.
Okay, thanks, Jason. So good morning, everyone. And again, I'm 𝗂𝗃𝗄𝗵, and I work at Western Washington University in John Ribzik's lab. And so, yeah, this talk is about sediment accretion in the 𝗃𝗏𝗄𝗆 River estuary. So many of you know that sediment accretion is really foundational to marsh maintenance and recovery. And when I say maintenance, I mean keeping pace with sea level rise. And by recovery, I mean recovering from any subsidence that might occur while a marsh is diked and drained and not being flooded regularly. If there's a lot of subsidence that occurred, it can take a lot of sediment to recover from that lost elevation once you've removed a dike. And I say it's foundational because so many processes are affected by elevation in an intertidal environment. So I might be biased, but I think it's foundational, both literally and figuratively. Unfortunately, many of the world's deltas have a lack of sediment. And that's all those deltas shown in the red zone right there. This means that those deltas don't have enough sediment to maintain themselves in equilibrium with sea level rise, let alone build up extra sediment after restoration. So restoration may not be so successful in those systems. And it's often because of dams in the watersheds, but there can be other reasons too. So what we want to know is, how do our Puget Sound marshes fare in this regard? Do our deltaic marshes have enough sediment for maintenance and recovery? So our lab at Western, we've been monitoring sediment dynamics in a number of Puget Sound estuaries to get at just this question. And we've been using a combination of surface elevation tables, dated cores, marker horizons, and modeling. And we've been doing that not just in marshes, but in seagrass meadows and tidal flats, mud flats too, but today I'm just going to be focusing on marshes. And what I hope to show you with this presentation, the bottom line really is some good news. So our evidence shows that active deltaic marshes in Puget Sound appear to be accreting enough sediment for both maintenance and recovery. So they look like they're keeping up with sea level rise, and they're also doing a good job of recovering lost elevation once they're restored. So for the rest of this talk, I'll mainly focus on our work in the 𝗃𝗏𝗄𝗆 River estuary, since we have the most extensive data set there. But I'll also mention data from a few other deltas just for quick comparisons. And so here's these sort of two main questions. First, are they, we'll look at just natural marshes to see if they're accreting enough just to keep up with sea level rise. And then we'll look at our restored marshes accreting more. So the first question. Here's a map of our study sites within the 𝗃𝗏𝗧𝗃 River estuary. And the zone that's circled there in red is the marsh area that was restored in 2012. It's about 150 acres. All the other outlined zones are what I'm calling natural marshes. We have a network of 20 surface elevation tables, also known as sets, that we have used to measure elevation change. So at each of those sites. And first I'll show you what we found from the natural marsh sites. So all those zones outlined in white. So from 9 years of monitoring elevation change at those sets, we've seen that the natural marshes in the 𝗃𝗏𝗧𝗃 have been gaining about 1 centimeter per year on average. And 1 centimeter per year for a natural marsh is a lot. Of course, there's some variation from in different zones of the estuary, and that one area is gaining quite a bit from more than the others. But even the lowest rate there is greater than the local rate of sea level rise. We also have some sediment cores from the same sites that we dated with radioisotopes like lead-210 and cesium-137 as part of a blue carbon study. And those cores provide us with just a slightly different measure of long-term accretion rates on like a 100-year time scale. And the dated cores gave us an average accretion rate, again from the natural marshes, of 0.6 centimeters per year. So the set rates of elevation change were higher than the rates from the dated sediment cores, and nearly twice as high, in fact. And this might be due to just differences in how the rates are measured, maybe due to different methodological timeframes. But regardless of why they're different, I just want to emphasize that both the rates are higher than the current rate of sea level rise. So it's looking like our natural marshes in the 𝗃𝗏𝗧𝗃 are able to maintain their elevation relative to sea level. And now we'll just skip over to the nearby Snohomish estuary for a quick comparison. We also have some dated sediment cores from the 𝗂𝗂𝗶𝗴𝘁𝗀 marsh, which is an undisturbed marsh in the lower Snohomish estuary. And those cores are showing, again, a decent accretion rate of 0.5 centimeters per year. And so that the 0.5 is similar to our 𝗃𝗏𝗧𝗃 rate of 0.6 centimeters per year from the sediment cores. And also, again, higher than the rate of sea level rise. So now that we've looked at what's going on in some undisturbed marshes, let's move on to some recently restored marshes to see if they're accreting enough sediment to recover from subsidence. So back to the 𝗃𝗏𝗧𝗃 again, and this time focusing on the restored marsh in red. That restored marsh experienced up to 1 meter of subsidence prior to restoration. So it's going to need a lot of sediment to recover that elevation. And our sets in the restored area show that it is gaining about 2.5 centimeters per year on average. Generally, well, it's more than 2 times the rate in the natural marshes on average, except for that one weird area again. And these rates have been fairly consistent for the last 6 years. So this is great. That's a very high rate. And now we'll just take a peek at a couple other estuaries, the Skagit and the 𝗂𝗃𝗏𝗃, where others have given us permission to mention their set results just for a point of comparison. The nearby Fur Island Farm restoration site in the Skagit River estuary is also gaining a high rate of 1.7 centimeters per year on average. So 1.7 is a bit lower than 2.5, but it's still quite high. And these sets have been monitored by Washington Fish and Wildlife. And then at the southern end of the sound, the Nisqually Delta's restoration site has been pretty steadily gaining about 0.5 to 1 centimeters per year since 2015. So a bit lower still, but still higher than the rate of sea level rise. And those sites there have been monitored by USGS. I know I bounced around a bit, so here's a summary of those sets results from that handful of restored marshes. Now, one restored marsh will not be exactly the same as the next, of course. There are certain conditions that will differ between them, and those conditions can affect the accretion rates. For example, one might have subsided more than another before it was restored, which could lead to greater accretion rates when you have greater accommodation space. Second, since the time since dike removal can make a difference. And so we would expect a site to have a higher rate of accretion initially, and then gradually the rate will decrease over time. And third, they just have different sediment supply available to them, of course. Maybe some rivers are dammed and others aren't. And some sites may have easier access to that riverine sediment than others. But overall, this just starts to give us a sense that the Stillaguamish rates may be a little higher than other restored marshes, but all of what we've seen so far has indicated that restoration is worthwhile to do here. Restoration seems to be successfully recovering that important process of sediment accretion. So here's that take-home message again, and it's good news that our active deltaic marshes in Puget Sound appear to be accreting enough sediment for both maintenance and recovery. And I realize this message might not be earth-shattering, but remember all those other deltas of the world I showed you earlier that are not so lucky. And I had a feeling that maybe not all of you are aware of just how lucky we are to have sediment here. So this is just an attempt to start your day off with some good news.
Katrina, you're at 2 minutes.
Thank you. Just a couple more slides. Now there are a few caveats to that last statement that I'll mention here since I have a couple minutes. First, it is possible to have marshes growing in the vertical dimension, like I showed you, but perhaps not growing in the horizontal dimension due maybe to waves that are eroding the marsh edge. So that can be another complicating factor. Second, this doesn't mean that every deltaic marsh in Puget Sound is necessarily doing well. Obviously, this is just a few estuaries that I showed you. And there are parts of deltas, even within deltas, that may no longer be actively growing, where the river may have changed course, and we might expect accretion rates to be lower in those areas. But so far, the data we've seen have been promising. So I think that expanding our network of sets and cores, both in natural marshes and in restored marshes, will help us to better understand these sediment dynamics as it relates to restoration. So I'll just put out the call that if anyone else has sets or cores out there, and I know there are some more out there, that you would like to add to the mix. I think they're being established in a number of different systems now, and we might be able to start thinking about working on a larger synthesis. So let me know if you're interested in that. And just a sneak peek into what I'll go into more in the proceedings. One implication of high accretion rates is that high accretion rates also often means high rates of carbon sequestration, which is a whole other topic, but really restoring the ecosystem process of carbon burial goes hand in hand with restoring resilience to sea level rise, and can be yet another motivation for marsh restoration. So that's it. I just have a slide for questions.
Great. Thanks so much, Katrina. That was a great talk to start off our day. We have a lot of questions coming in. So Jenna, do you want to start fielding those?
Yep, I think we have time for one. So Kathleen asks, is the Stille rate of sediment accretion due in part to the Oso landslide input?
That's a great question. We started, the sets in the restored site were actually installed in 2014, which was the same year as the Oso landslide. But since then, we haven't seen, if it was largely due to the Oso landslide, we'd expect to see a blip in that year or maybe a few years after the landslide, but we haven't I've scrutinized, the time series data that we have, and I haven't really seen a huge difference starting in that year. But I know Eric Grossman is really interested in this question, and so he might like to talk to it too. He might actually disagree with me.
So I think that was it for time on questions, but there's a lot to answer in the chat and Q&A.
Great. Thanks again so much, Katrina. And Mike Lemoyne, if you want to start sharing your screen, please. And Mike is with the Skagit River System Co-op, and his title today is Multi-Scale Evaluation of Chinook Salmon, Responses to Estuary Restoration in the Skagit Tidal Delta. Your slides look great, Mike, and take it away.
Thanks, Jason. Can you hear me? Good. So today I'm going to be presenting a lot of the monitoring work and analyses that Eric Beamer and Corey Green have done over the last few years, and specifically highlighting the responses that we're seeing at different scales. So if we think of recovery plan, going back to the original Chinook recovery plan, it's based off of population scale demographics. So specifically abundances and productivity changes over time. And these are set to, from our understanding of population dynamics, we then set recovery actions that occur also at different scales. And get on my screen here. And generally on the management side at the population scale, we see how we manage hatcheries and harvest to try to achieve our recovery goals. And what I'm specifically going to talk about today is habitat, specifically associated with restoration, that generally happens at a site. To go back to the original recovery goals and how we define them, we usually use stock recruitment curves where we have adult spawners and adult recruits. And we develop a stock recruitment function that goes through it, generally like a Ricker model or a Beveridge-Holt model. And most of these models support density dependence, where as adult spawners increase, we don't get as many adult recruits. And from this, we define population dynamics as productivity, R, or carrying capacity, K. So we develop a current trend of population dynamics over a period of record of a few decades, primarily from spawner data and catch data. And then we develop new goals to try to suggest what abundances we need and how we need to shift that stock recruitment function to achieve recovery for said population. This acknowledges that the population uses a specific spatial and temporal extent. For Chinook salmon specifically, they use everything from the river all the way out to the Pacific Ocean, so thousands of miles. And this can be overwhelming to develop a recovery plan, especially when we think of the open ocean. So often we come up with stage-specific frameworks to think about what each stage of that population and what type of habitats they use. Specifically, we talk about estuaries that you've seen numerous times in this talk, that Chinook salmon fry sub-yearling rear extensively in estuaries. And this usually occurs during a time period of late winter to early summer. And so restoration actions that happen in the estuary happen at very specific sites in the estuary and generally not across the entire estuary. And this occurs within a specific population extent. So talking about the Skagit, we've had a number of projects that have occurred within the Skagit estuary, highlighted here in yellow. And these occurred at very specific sites. At these specific sites, we have done a number of 𝗏𝗏𝗃𝗏 evaluations, which are before-after control impact, to measure the effect of the restoration given the time sequence that occurs. Because restoration usually has to occur over a period of time where you have a before condition and after condition. And we normalize that to the time differences or the differences in the seeding populations from the Skagit. So here we could see that in before, what we hope to happen is that we have a reference condition and we have a total number of Chinook, and a restoration that is somehow less than the reference condition, and we want to bring it up. And then after the restoration action, restoration, and reference should meet one another. Simply by doing this work at a site for a specific project, we can develop some understanding of how that project occurs and develop new knowledge to inform future projects. But if we're achieving recovery, we do have to come back to that population scale that was established in the original recovery plan, that stock recruitment dynamic. And so we need to see if, hey, has productivity increased or has carrying capacity increased in the system? And generally for the Skagit, we have for our different stages, primarily for freshwater rearing and estuarine rearing, that we seem to have capacity limited, where there's a strong density dependent relationship. As migrants come out to the estuary, they seem to incur either high mortalities or they migrate out quickly to the bay and have a low smolt to adult return. So does restoration lead to species recovery? When we think here in the Skagit, we understand that our recovery goals are established at the population scale, but restoration occurs at the site scale. So this really means that we need to evaluate both at the site scale and restoration scale. So to get into some of the results, we have seen that projects that result in dike breaching or dike setbacks or removing fill from tidal channels have actually resulted in similar conditions, similar Chinook abundances as reference conditions, and we're matching. But those sites that still limit natural function, limit natural tidal exchange, don't operate as reference conditions, and thus we're not getting as much bang for the buck in those type of sites. And I just want to acknowledge that this general context where we want to think of channel allometry, we want to think of natural channel inundation, comes from a lot of years of monitoring and a lot of sites to get those general ideas. But now we know that supporting natural process, and a lot of what Greg's work has been doing and what he's probably talked about in this session or in the previous sessions, really highlights that if we follow channel allometry, we'll get the Chinook back. The other thing that we've been seeing is that location matters. Josh highlighted this in the Snohomish. And really, landscape connectivity seems to associate very strongly to densities of Chinook on the landscape. And so if we think about restoration actions happening in a low connectivity area, we may only be able to have so much recovery potential. Where higher connectivity site, let's say here on the North Fork, could have a higher potential. So understanding where a restoration action or recovery action happens in the landscape is also an important consideration and a generality that we're seeing in the Skagit. At the population level, with more current analyses, we still see that there is a density dependent relationship. That means there's still not enough habitat out there to meet our recovery goals. However, there's some promising trends that we're seeing in the data. One is that the average size of fish in the delta related to the amount of outmigrants from the river seems to be positively associated with the wetland area. So as we add habitat, our fish seem to be getting larger. Larger fish generally have higher survival. We're also seeing that they're residing, as we have more restoration occur on the landscape, they're residing more within these estuarine habitats. And we know from bioenergetics work and diet work that they grow quite quickly in the delta habitats, which is another benefit. But we're still not seeing it in the stock recruitment relationship, which was established in the recovery plan. But our hope is that if we're retrieving recovery, that we see the stock recruitment curve change, and hopefully change beyond the confidence limits of the current dynamics, so it can be, if not significantly different, at least apparent. So some of the generalities that we're understanding at the local Chinook responses is, if you build it, they will come. If in our situation, if we have habitat that is ag land and we inundate it with water, there will be some fish there. But some restoration projects do better than others. And it's those projects that try to mimic natural process. such as channelometry, tidal inundation cycles, that work much better than those that have muted processes with tide gates and such. Location looks like it could matter, where those areas that are more connected to the outflow or to the source, which is the outmigrating fry, have a potential of more, or have a higher recovery potential. At the population level, it seems like Chinook salmon are becoming less crowded with restoration. And that's having kind of some individual responses where we're potentially seeing larger fish, so higher growth rates, and we're seeing longer residence. Got ahead of myself there. There are some slight indications that I haven't shown here that higher smolt to adult return rates based off of habitat increases, but more is yet to come on that one. We're currently working on that. But I have to say that there are future uncertainties. Being in this game a short period of time with Eric, it seems like getting support to do monitoring can always be a challenge. Yet I want to take this time to highlight every species within the US that's listed under ESA that has been recovered has attributed it to adaptive management. And that's from doing recovery actions on the landscape and monitoring them and learning from them.
Mike,
Even
we have 2 minutes.
Mountains, thank you, this is my last slide. Even mountains of literature throughout highlight that adaptive management is absolutely critical for species recovery. So, and if we think about that in the estuary and recovery of Chinook, we need to make local scale observations where we're trying to improve future actions from the evaluations that we're doing on the ground. And we're also identifying new problems. One is climate change that many of you have talked about, but another one is non-native species, non-native vegetation species. Greg and I are trying to get our head around invasive cattail, but I'm also seeing other non-native fish species kind of blip more and more and more in the Skagit Delta. At the population scale response, is recovery happening? One fundamental aspect of the count-based demographic models that we use, which are stock recruitment curves, it takes a lot of years of data. Every year is an N of 1. So it takes a lot of years to determine change. And so it just takes some time. In addition, as we think about some of these restoration projects, we're also having natural losses across the landscape. So the pace of recovery is maybe not sufficient to expect that we would see strong changes in response at the population level in 20 or 30 years. So at this point in time, I believe we've only have something like a few hundred hectares restored at this point in time, where the recovery plan was asking for, I believe, 1,200. So we may be only at a quarter of a third of what was intended to be recovered in the recovery plan. So with that, that's all I have. Thank you.
Great. Thanks so much, Mike. Right at 12 minutes. Nice job and great talk. All right, deep breath. Let's see, Jen, are there questions rolling in?
Yep, one just came in from Eric. It says, I acknowledge your data indicate greater growth and survival in marsh settings, but what is the state of knowledge, confidence in growth and survival rates, adult returns related to Chinook use of eelgrass meadows? Can they partly compensate for lost marsh? And are you able to provide potential productivity numbers per unit of area of eelgrass like you have for marsh?
I do not have an answer for that question. So we do not generally collect information within eelgrass specifically. So.
Okay. And then there was a question before that looked like Paul and Devin both answered, but I'll let you speak to it as well. So Stephanie asks, what type of fill removal projects did you refer to?
Oh, there was a rainbow. There were 2 fill removal projects on the Swinomish Treaty Trust lands, Rainbow Marsh next to Rainbow Bridge, another one on Swinomish. I'm forgetting the name of it right now, but just north of the Rainbow Marsh one, both across Swin Channel from LaConner.
Okay, thank you. That's all I'm seeing.
Okay.
Great. Thanks
everyone.
a lot, Mike. And Corey Green, do you want to start sharing your screen? And for those with more questions for Mike, remember to keep typing them in and put his name at the start of it so he can keep typing in a response. Next up is Corey Green. He's with NOAA Fisheries at the Northwest Fisheries Science Center. And I saw his video feed pop on there, so I know he's there. His title is Density Dependent Habitat Limitations for Juvenile Chinook Salmon in Large River Deltas of Puget Sound. Your intro slide looks great, Corey. Take it away whenever you're ready.
Thank you. Can you hear me?
Yep.
Thanks for everyone for coming. This is sort of a broader perspective compared to what Mike was talking about across Puget Sound. And it's basically a big project that we just wrapped up for ESRP. And a lot of people were involved. And so I'd like to thank all these co-authors, not only from NOAA Fisheries, but also from tribes and WDFW. A lot of funding went into this, including a bunch from ESRP, but other sources as well. And I'd also like to thank a technical review that really improved the results of these studies. So just to start out with, we've been talking a lot about Chinook salmon estuary restoration. Know that there's been a huge amount of wetland loss in Puget Sound, depending upon where you go, between 70 to 99%. Many large restoration efforts have been put forth to counter this effect, with the goal really of improving conditions for threatened Chinook salmon. And the key assumption here is that as you add more habitat, you're adding more places, more safe places for juvenile salmon to rear before they enter the marine waters. And so there's that key assumption that estuary restoration is increasing capacity. And so what we wanted to do here was, well, we sort of got a foundation in the Skagit. How does that apply to other systems, particularly in light of the fact that Chinook salmon are listed? And so in some places there might be low numbers of fish just due to the fact that we have low numbers of adults returning. And so this sort of going back to Mike's point about these density dependent relationships, which underline this concept of capacity. We have fish shown on the left side here, fish in the delta as a function of migrant phi moving downstream each year. And you see this sort of leveling off that capacity relationship. And so the expectation is that as we're adding in habitat, we're improving conditions for fish, and then sort of adding more capacity. And that hopefully is translating to a productivity effect as we look at sort of fish moving from out migrating to adult return. But so how does this play out in other systems that are less well studied over a long-term period? And so these general questions are what I'm going to address today. Are there systematic density-dependent patterns in abundance across 4 river deltas, Nooksack, Skagit, Snohomish, and Nisqually? And under what conditions do we observe high densities? And what are the applications to salmon restoration recovery? So what we wanted to do is build the stock recruit curve from 4 different systems. And so those are represented as the different colors in this little cartoon here. Here we have basically a density dependent relationship defined by recruits and stock. In our case, the recruits are natural origin sub-yearlings captured within deltas. And so that's an example of 𝗙 trap catching fish. We also use beach seines and basically corrected those count data by the area swept or sampled by those nets, and also by capture efficiency of those different net types. And then we have individual observations, many of them across habitat types, the season, and multiple years. Our stock in this case are out migrant trapping efforts, and we sort of summarize trapping based on all sub-yearling out migrants, those fish which are likely to use deltas for rearing. And then sort of they're reported by week and linked back to our measures of fish in the delta. And then to really compare apples with apples, we corrected these numbers for a wetted channel area estimates in each delta, and that allows us to get sort of a good comparison between a small delta like the Nooksack to a large delta like the Skagit. And it also puts these axes in the right sort of comparison. On the this axis, we have sub-yearlings measured within the delta per unit hectare. And then the x-axis here, that stock is natural origin out migrants per hectare of delta channel. The third bit, we need to do a curve fitting exercise. And so we basically assumed a Beaverton-Holt relationship and tested that against a density-independent model, a sort of null hypothesis of no density-dependent effect. All right, so here's these 4 systems. There's a lot of sampling in each of those, and those are noted in various places within the deltas by those dots on the right side. Basically, we have over 7,000 observation of fish in these 4 deltas, up to 19 years of data, basically 26 weeks within each season, and then all those sites add up to quite a few. That range and sort of connectivity and different habitat types. And as these histograms show, there's a huge amount of variation. So the gray shows the fish, the outmigrants, black shows the natural origin fish captured within the delta, and the white is hatchery origin fish captured in the delta. And so as you can see by all these axes on those histograms are log transformed, so there's a lot more variation than just sort of observed, but when you do the log transformation, you get pretty much a good overlap in instantaneous observations, even though you can still see pretty big differences in the modes as you go across systems. On the right panel there is basically the proportion of observations where we caught at least 1 fish in each of these sampling techniques. And you can see some variation there. For example, in the Skagit, within the season, if you stick a net in the water, you're much more likely to catch natural origin fish than hatchery origin fish, and the reverse is somewhat true in the Nisqually. All right, so let's put all this together and produce our stock recruit function. So here are all the data, and those different systems are represented by the different colors. And the black line is the prediction, and there's some gray confidence intervals around there. And that this illustrates a couple things. First, that curve that we fit was a much better relationship than a density-independent relationship, and that can be seen a little better when you look at the recruitment rate, which is basically the y-axis divided by the x-axis. You can see a strong negative density-dependent relationship across the range of measurements of densities that we obtained, and consistent within each of the 4 systems that we were sampling. This also allows us to do sort of an estimation of what capacity is based on that curve. And the actual capacity is off the graph. It's a theoretical result. And so we used a slight modification, which is 95% of that capacity level, which is in the range of our data cloud here. So that occurs about 240 fish per hectare in the delta. That is a useful number in comparison to other measures of density dependent we independently obtained in our project. So one was prey selectivity. We saw a huge change in prey selectivity sort of over this range in delta densities. And also measures of otolith-based growth, which Melanie talked a little bit about yesterday, also show this density-dependent relationship sort of in the range shown here. And so what this illustrates is that you've got basically sort of a range of density-dependent effects as you increase the number of outmigrants, but also that this sort of line of capacity represents sort of a shift not only in the numbers, but also in some of these other demographic aspects such as growth. Okay, so we have all this information. Now we can use it to look at where we see, under what conditions do we see a delta capacity exceeded. And so we can look at the proportion of observations surpassing that 95% capacity level. In this case, we're looking across different periods of the season. And so we see several big patterns. First, there are big differences among systems. So Skagit compared to Nisqually, Skagit's much higher likelihood to surpass capacity than the Nisqually. We also saw strong seasonal patterns in capacity exceedance. So compare the Skagit with the Snohomish. The Skagit surpassed those levels earlier compared to the Snohomish. And we also observed, if you looked at those dashed lines, patterns in basically when you add in the effect of hatchery origin fish, in at least 2 systems, the Nisqually and Snohomish, we saw an increase in the proportion of observations surpassing capacity when those fish were present. And so in the Nisqually was particularly strong on the order of 2 to 3 times the effect without considering hatchery origin fish. We can also annualize these results. So basically take the data and look at the proportion of observations in each year, and then compare that with the annual estimate of outmigrants measured at the trap. And we see here that that produced a sort of density-dependent effect of its own, with Nooksack, Nisqually, and Snohomish sort of linearly increasing to this cap formed by the Skagit data. And that sort of inflection point occurs around 10 to 20,000 annual outmigrants per hectare of delta channel. And that 20,000 pretty much lines up with what was estimated as capacity in the Skagit recovery plan. And so basically, you also saw big differences among systems. Each of these data points show that capacity was exceeded in each system for some portion of almost every year, and that you had this strong inflection point.
Corey, you're at 2 minutes.
Thank you. It also illustrates that there are some systems which are more likely to surpass capacity than others. So a final point I want to bring up is the sort of high densities. These sort of fly in the face of the sort of theoretical idea of capacity that you're sort of reaching a cap. But we did see observations 2 to 3 orders of magnitude higher than the capacity level. And so we were wondering whether there was some systematic patterns and where we saw those. And so we looked at different habitat types. So first, 3 wetland types, forested riverine tidal, estuarine forest transition, and estuarine emergent marsh, basically a connectivity gradient from river to more marine. And then also different channel types, blind channels versus distributaries. What we saw was that there was this sort of step order function. When you looked at the 95th and 90th percentile, those were those high observations of fish per hectare. Basically, you had basically 2 times that high number when you compared blind channels versus distributary, and within those you saw this gradation of forested riverine tidal to estuarine emergent marsh, and basically sort of following that connectivity gradient. So basically, fresher, more connected, safer places were much more likely to have these high densities, which were sort of in that place where you'd expect to see strong density dependence compared to less connected, more saline environments. So this variation in density sort of also begs the question is whether sort of our metaphor of capacity, this idea that the habitat is filling to some place and then your cup runneth over, is actually true. And so the prediction would be that if you sort of plotted probability of presence as a function of outmigrants, you'd gradually fill until you reached a particular level of outmigrants in which you're basically spilling over. So we can ask whether that's true in our data. And what we saw is like some patterns that sort of are somewhat according to this, but really mostly not. And if you look at Nooksack, you do see this general increasing pattern, but there's no leveling off across the entire range of outmigrants. In the Skagit, maybe it levels off for basically the entire range, but you don't really see that in the Snohomish and the Nisqually, and you see a lot of observations in which basically you don't have observations with fish. So in Nisqually, basically we're down up to 25 to 50%. Nooksack about the same. Even in the Skagit, you still, at these highest levels, you still have a lot of observations with no fish. And so that maybe should put us to rethink this idea of capacity in large river deltas. Maybe these old metaphors like a cup filling or a hotel rooms filling up until you reach no vacancies, maybe we should rethink those, at least put in some spatial variation, thinking about, say, for multiple cups or like the Champagne Tower, or multiple hotels connected in various ways to your sort of source of people. And even a better metaphor might be the way people think about capacity in transportation, where you have sort of the best routes filling up, even as sort of many other routes through a system remain free for traffic. And so in summary, basically we have 4 systems. Those results illustrated that capacity was exceeded in all systems in certain weeks and years. Hatchery releases can increase the likelihood of exceeding capacity. And then you have these high values of density, basically those more fresher, connected, safer habitats. Those data can be used to basically predict exceedance of capacity in other systems where you basically maybe have outmigrant trapping but no fish sampling in the delta, or vice versa, and also to improve predicted benefits of estuary restoration. Let's sort of hammered home from multiple talks, those more connected sites and those blind channels which fish seem to particularly prefer. And so if you'd like more information, there's a report and the webinar we gave a couple weeks ago on the Sailor Sea Wiki. And with that, I'd be happy to answer any questions. Thanks.
Great. Thanks so much, Corey. Jenna, what do you think? Should we do one quick question? And Sarah Breslow, if you want to start sharing your screen, that would be great.
Sure, we can do one question. So Paul asked, would it be fair to summarize that the greatest pressure on habitat use in the Snohomish is happening as fish pack into freshwater tidal habitats later in the season?
I think it varies. If I got that question right, let me just make sure I understood the question. Can you repeat that?
Yeah, sorry, I read it kind of quickly. Would it be fair to summarize that the greatest pressure on habitat use in the Snohomish is happening as fish pack into freshwater tidal habitats later in the season?
In the Snohomish, yeah, I think that would be a fair statement, that you saw the peaks in both not only juvenile salmon, but also, or juvenile natural origin salmon, but hatchery origin salmon later in the season. And so if, for example, there was a management efforts resulted in a broader distribution of fish across that time, that might alleviate some of the density dependence that occurs in those peaks.
Thank you.
Great. Thanks so much, Corey. And moving on to Sarah Breslow at the University of Washington, whose title is Complex Tools for a Complex Problem, Anthropology and Political Ecology in the Service of Salmon Recovery. Take it away, Sarah.
Thank you, Jason. Hi, everyone. I believe I'm the only anthropologist at this summit. So now for something very different. We typically read our talks, so settle in for some story time and I'll dive right in. Disputes over habitat restoration have earned the Skagit Valley in the northwest corner of Washington state, which you all know, a reputation for being mired in intractable conflict. Goals of recovering salmon and protecting farmland are seemingly pitted against each other in competition for the same land. At stake are salmon runs essential to the Puget Sound, farmland that produces a large portion of the world's spinach, cabbage, and beet seed, and the future of local farming and tribal communities. Since white settlement in the mid-1800s, the Skagit lost 40% of its river floodplain habitat and 98% of its estuarine habitat to agriculture and development. By 1999, Puget Sound Chinook salmon were listed as threatened under the ESA, as all of you know. Now, while Native Americans and environmentalists attempt to restore lowland habitats for salmon, farmers and farm advocates attempt to protect arable land from encroachment by development and restoration. Public discussions regarding habitat restoration largely concerned its biophysical details, such as fish productivity, tide gate design, and trade-offs in acreage. Yet I argue the dominance of this techno-scientific discourse masks the deeper social, cultural, and historical roots of the persistent conflict. In this talk, I aim to show how the fields of anthropology and political ecology, which is a subfield of geography, can provide new and hopefully helpful insight into such humanistic dimensions of ecosystem management. In the early 2000s, I studied 3 central stakeholder groups in the Skagit: tribal, agricultural, and environmental, and asked, why is there a seemingly intractable conflict over salmon habitat restoration in the Skagit Valley? During 2 years of ethnographic fieldwork, I interviewed more than 150 people, attended more than 50 meetings and events, and went fishing, rode a tractor, attended a tribal ceremony, and helped collect biological data. Through analyzing my notes and other documentary research, I identified multiple historical, legal, and cultural explanations of the Skagit conflict. Here I will focus on my qualitative cultural results. First, my research participants disagreed on the causes of salmon decline. They did not agree on who was to blame for destroying the fish, and therefore they did not agree on who was responsible for recovering them. For restorationists, it seemed the central unfairness was that while logging was restricted, agriculture had been allowed to thrive at the expense of salmon. On the other hand, farmers could still remember a heyday of fishing in the 1950s, even though their fields dated to the 1880s. They reasoned the problem was not habitat loss, but overfishing, including tribal fishing, and they felt unfairly punished for salmon decline. For a tribal interviewee, the central injustice was the decline of salmon and the tribe's inability to harvest them was caused by non-tribal commercial fishing and development of their traditional homelands, which they had ceded in exchange for reserving the very right to fish. In these ways, my interviewees constructed the problem, its causes, and its rightful solutions in mutually incompatible stories. These disparate perceptions of the central problem arose from distinct yet equally complex realms of experience and knowledge. And here I'm going to share some quotes from interviewees that I'm going to allow you to skim as quickly as you can, given my time limitation. Different realms of experience and knowledge, what it takes to run a successful agricultural business, what it takes to restore a river, and what it takes to manage a sovereign tribal nation. My interviewees would assert that others should be better educated about their respective world in order to reach a fair and effective solution to salmon decline. Further complicating things, interviewees differed in what they accepted as legitimate forms of knowledge. Both farmers and restorationists learned from science, agricultural and fishery science, and both learned from place-based experience, working the land, and biological fieldwork. But they differed in the weight that they assigned to science versus experience. Hence, a farmer could dismiss environmental professionals as, quote, armchair experts, and an ecologist could dismiss landowners' environmental concepts as, quote, pseudoscientific. Lack of respect for each other's knowledge claims contributed to their disagreement and to their mutual distrust. Even more complicated was that axes of mistrust, disagreement, and perceptions of unfairness were not aligned. While farmers blamed fishing for salmon decline, their distrust was directed primarily at restorationists, who they perceived as urban outsiders, trying to impose an environmentalist agenda on their working landscape. Meanwhile, although the local tribe's proximate contenders were area farmers, tribal members expressed distrust of white people in general, incurred through historical and ongoing persecution. Finally, restoration advocates expressed mistrust of people in general. They felt that since everyone was at fault in environmental degradation, everyone needed to be part of the solution. But they doubted that there was the political will to recover the ecosystem sufficiently to make it habitable for both people and fish. What was at stake in all of this disagreement and mistrust? I found it was much more than natural resources. Rather, it was the identities, communities, and moral commitments of the people who created and depended on the landscape and its resources. Both the farming and tribal communities had been co-constructed with the natural resources on which they depend, such that they are place-based communities. And restorationists are becoming a community that is co-constructed with the landscape it is attempting to recreate. It is clear that farmers built the farmland, and some farmers expressed painful remorse at the thought of undoing the work of their ancestors by converting farmland back to habitat. What is less immediately obvious is that the landscape also made the farming community. Its people and social structure literally grew from the unique demands of cultivating a river delta. For thousands of years, Native Americans also developed a complex social system, including marriages across watersheds that enabled them to cope with a dynamic landscape. It is less recognized that Native people managed their environment to ensure a stable food supply, such as through clam gardens, intentional burns, and camas prairies. While Skagit farmers narrated stories of migration and homesteading, Coast Salish people, quote, tell how they were either created or dropped from heaven on the spot they now occupy. Although restorationists did not trace their ancestry to the valley, and many commuted daily for their job, there is also an observable coevolution of community and place around salmon recovery. While restorationists are changing the landscape by restoring habitat, salmon are shaping the social organization of restorationists. From mountains to the sea, salmon transect a multitude of jurisdictions, such that their protection has mobilized an unprecedented coordination of people and organizations in the region. People who view restoration as an essential ingredient for salmon recovery and for the health of the planet in general. With such deep-seated senses of place and uncompromisable stakes, my interviewees expressed predictably different philosophies toward the landscape and its human inhabitants. Ultimately, they disagreed on who should take care of the land, who should be responsible for creating and maintaining its productivity. For farmers, it was farmers. For Native Americans, it was tribal land managers. And for restorationists, it was nature herself, in the form of the river set free. These tangled social relationships and divergent philosophies are not new or unique to the Skagit Valley. They have identifiable historical roots. They resonate with broader cultural narratives, and some have been institutionalized in governmental policies. As part of the wider conservation movement, habitat restoration reproduces the values of Western Romantic environmentalism and scientific managerialism introduced by 𝗵𝘀𝗃𝗃𝗃 in the 19th century. Yet in the words of historian Samuel Hayes, such a philosophy promoted, quote, scientific calculation of material benefit, unquote, over democratic decision-making. Already by the early 1900s, what Western farmers, ranchers, and foresters had in common was, quote, violent revulsion toward the environmental professional who in their experience had become, quote, simply a bureaucrat whose decisions a local group could rarely affect, unquote. Skagit farmers and restorationists inherit a relationship of distrust that dates at least to the early 20th century and is found worldwide. Meanwhile, as environmentalists and fishermen have been documenting the century-long decline of salmon, farmers have been preoccupied with their own drama of loss, that of farmland, reflecting a larger American anxiety about loss of the family farm as the population shifts from rural to urban. Anxiety about losing, 2 minutes, anxiety about losing farmland and with it, good soil takes place within a centuries-old Western paradigm of what it means to be a good farmer. The ethic to create and farm arable land has been actively promoted by the US government through promoting white settlement, wetland reclamation as a patriotic duty, and since World War I, agricultural industrialization. A maximum yield philosophy drove agricultural production, just as it did early models of resource conservation and fisheries today. Finally, the tribal members I listened to evoked a story of profound loss that has already occurred. The lasting effects of losing land, people, culture, language, and spirit is termed historical trauma. The Swinomish Mental Health Project explains its effects can be treated by, quote, promoting Indian cultural identity and strengthening the Indian way of life, which, as we know in the Northwest, centers on salmon. At the same time, this story of loss is now coupled with a proud narrative of cultural and economic revitalization, buoyed by the tribe's growing legal and political power and a worldwide Indigenous rights movement. The themes I'm discussing are not unique to Skagit and have been identified by social scientists as key features of environmental complexity and conflict. Social hierarchies and injustices divide local communities, and we must take care not to exacerbate them. Social scientists and managers are also cultural beings with values and attitudes that can affect local social dynamics. Disagreement, different sources of legitimacy, and lack of trust are interrelated. Senses of place are real and can powerfully affect how people respond to conservation. Environmental disputes may be the artifact of complex, changing, or conflicting in governmental laws and policies and are not necessarily due to lack of scientific understanding. And finally, language matters. The dominance of technical language in conservation masks its underlying social factors. We need a richer language that can capture and therefore help us attend to the social as well as ecological complexities of ecosystem recovery. So to wrap up, I am going to suggest that defining your social goals for restoration can help attend to those social dimensions and include social science in your work. Thank you, and I'll share some resources to help think through those social goals and references to read more about the Skagit case. Thanks so much.
Thanks, Sarah. That was a really great talk. Jenna, do we have any questions rolling in?
Yeah, we have, first of all, a lot of comments just with admiration and respect and appreciation for the talk. We're really happy to have this. First question is from Jenny saying, when COVID limitations lighten, can your play on this topic be revived again?
I would love to talk to you about that. That has been on the back burner for a long time. She's referring to the fact that I turned some of my interview transcripts into a full-length theatrical documentary. It's never seen a full production. if you're interested, please get in touch. Yeah, let's do it.
Okay, wonderful. And we have one more question. Emily asks, given when you collected your ethnographic data, do you have a sense if perspectives have changed since then?
That's a great question. Unfortunately, I really completed this work in 2011, and I haven't gone back to do any more truly ethnographic research. I've kept in touch with the issues a bit. I have a book ready to be written, which is my dissertation, and I've been wondering if these themes still resonate. Let me know. I think they do, from what I've heard informally. I think they do, and if so, I'll be more motivated to complete that and share that work in a full-length book with all of you. I really did this work for you, for this community, and so I hope it's helpful.
Thank you. Great job.
Thanks so much, Sarah. And yes, finish that book. I think a lot of us would read it. Jenny Baker, if you want to start sharing your screen, please. Jenny is with WDFW. And Jenny's talk today is Estuary Restoration Strategic Assessment, aka Skagit Hydrodynamic Model Project. Your slide looks great, Jenny. Take it away.
Okay, and can you hear me?
Yep, all good.
Wonderful. Okay, great, thanks. Wow, I'm following a pretty amazing presentation. So thanks, Sarah. I'm going to talk today about a project that prioritized restoration actions in the Skagit Delta by integrating best available science with the many community interests that exist on this landscape and the local knowledge that exists there. So this reflects needs and interest in the Skagit Delta, and so I'll start with some context about this area. The Skagit Delta is home to a vibrant agricultural economy and culture. The combination of rich alluvial soils and mild climate are found very few places other than this in the world. Skagit farms grow 90 different crops, including potatoes, berries, flower bulbs, and seed crops on 90,000 acres and generate more than $500 million annually. Products grown here are important regionally and even globally, as Sarah referred to. Skagit farmers grow 25% of the world's cabbage seed and 25% of the world's beet seed. Farming in the Skagit Delta requires flood and drainage infrastructure. Much of the land is subtidal, meaning that dikes keep water off farmland at high tide, and tide gates allow the water to drain off at low tide. Many of the dikes, tide gates, and drainage systems were built over 100 years ago. So at this point, they're getting a little old. Some of them are needing repairs, and they're not necessarily durable in the face of climate change. At the same time, there's the Chinook picture. Half of Puget Sound's wild Chinook come from the Skagit River, and Chinook are economically and culturally important to tribes. However, significant estuary habitat losses have contributed to declines in Chinook numbers, and the Skagit Chinook Recovery Plan calls for approximately 2,700 acres of estuary restoration. And now I'm shifting to acres because, unlike Corey and others, I'm talking to the public and we have to talk in acres. Some restoration projects have been completed, but more are needed. There's a limited land base, multiple needs, and competing interests. So how do we decide which estuary restoration project is next? We want to make strategic investments and build broad support for priority actions. So on to the project. This project didn't emerge out of thin air, and there were a whole series of events that I won't have time to describe. Jenna may get into this a little bit more after in the next presentation. But there were a whole series of events that led to the formation of the Farm, Fish, and Flood Initiative. And that's a group that formed to create and advance mutually beneficial strategies across farm, fish, and flood interests. And they initiated this alternatives analysis. So the goal was to develop a suite of projects that provide Chinook salmon estuary habitat and flood risk reduction in a way that protects and enhances farming and drainage. The result is a tool that provides transparency about both the benefits and the impacts of potential restoration projects to farm, fish, and flood interests. So who was involved? There were salmon advocates, districts who own and operate flood and drainage infrastructure, farm advocates, and scientists. The work group that guided the project was made up of a broad array of organizations representing farm, fish, and flood interests. The Department of Fish and Wildlife, NOAA, and the Nature Conservancy led the project. The work group also broke into smaller technical groups for detailed discussions about how the concerns and needs of each of these interests would be represented in the analysis. Additionally, throughout the process, we did outreach to the larger flood, fish, and farm communities to share our work and get input. And we hired technical experts and scientists to complete work that fed into the analysis. Okay, so it's an alternatives analysis, and we needed alternative actions or projects to assess and compare. This is a map of the 23 projects we included. These projects came from the Chinook Recovery Plan, the Skagit Flood GI, General Investigation, and also include new ones that the work group developed together. We purposely included many types and sizes of projects. We included dike setbacks, new distributaries, and new channels waterward of existing dikes. So all different types of projects. We wanted to look at a wide range of options, knowing that some would rise to the top and others would not. Okay, this is the framework we use to assess project concepts, and I'll spend some time here. You can see that each interest, farm, fish, and flood, received 100 points, and that's reflected in that middle column. And each of these groups, farm, fish, and flood, developed objectives that represented their needs and concerns, and those are listed on the far left. So for instance, a farm objective, one example, is prioritizing restoration on public land. We also developed corresponding measurable indicators for each objective because we wanted this to be a quantitative analysis. So for that farm example of prioritizing restoration on public land, the indicator was acres of public land converted to estuary. Subsets of the work group focused on farms, fish, and flooding, each met individually. They defined the objectives and indicators that were meaningful to them. So we didn't rely on the flood group to determine how farm benefits would be measured, or the fish group to determine how flood benefits would be measured, et cetera. In addition, each group got to weight individual objectives and indicators within their 100 points as they saw fit. So farm and flood groups weighted each indicator equally, but the fish group, where the scientists were and they like to tinker, that's my explanation anyway, gave more points to certain indicators and fewer points to others. You'll also note that some objectives represent benefits and some represent impacts. And I'll come back to this later in the presentation. As we developed the objectives and indicators, we then looked at what kind of analysis or science would be needed to calculate a score for each one. We used best available science, and this meant updating existing models and doing new analyses. So here's a list of some of the work that was completed. And then the outputs from these analyses were used to calculate scores for each indicator. And those results then allowed us to compare projects. And this science was the science updates and model updates were a really big part of the work, and they're really important. I don't mean by my offhanded comments to make it seem like I don't have the utmost respect for scientists. This was a really, really important part of the project. And so I just don't have time to dig into the details and show you examples, I'm afraid. Okay, another kind of complicated slide. The graphic on the right represents our process. It's very small text and you may not be able to read it. That's okay. The point here is that there are a lot of steps, each step represented by a box, and there's a feedback loop. So I'll spend some time on this slide as well. Once the technical analysis and that science was completed and we had results, we kind of did a gut check. Are the results meaningful? Do they differentiate between project concepts? And we actually ended up throwing out some objectives and indicators through this process. For instance, we were looking for a while at how much a project might reduce erosion, but the model didn't produce results that we felt comfortable with. A project might reduce erosion in one area, but generally it just shifted that erosion to somewhere else. And we weren't able to kind of put a number to it. So we discarded erosion as an objective. It was also through our process that we shifted our thinking from seeing every objective as a benefit and then separating out the benefits from impacts. Originally, when we started, we thought we would just list projects from 1 to 23 based on their relative benefits. But as we got into the results, relative level of benefit didn't always fit. For instance, when the farm group thought about converting more or less farmland to estuary, it was not degrees of benefit, it was degrees of negative impact. We really needed to reflect that meaningfully, and so we adapted our process and our products. We broke the objectives into benefits and impacts. So this all took a lot of listening for everyone sitting around the table, right? Understanding different points of view and thinking creatively to come up with something that everyone could genuinely support at the end. Okay, so this is a multi-benefit alternatives analysis. And so how do we do that? I'm gonna hope you can see my pointer. This graphic shows the process we use to quantitatively score each project. So you can see 2 projects are represented, one on the right and one on the left. And for each project, there are farm, fish, and flood boxes. And within each box, we have a column for benefits and a column for impacts. And each line with a number character in it represents a particular indicator or objective.
You're at 2 minutes, Jenny.
Okay, great. So for each project, we calculated individual benefit and impact scores for each indicator within each box. We normalized the score and then used them to calculate a total benefit and a total impact score for each farm, fish, and flood. And then they were summed to come up with a total multi-benefit interest, benefit, and impact score, and then plotted on a graph. Whew, that's a lot. What does it look like? When you plot them out, you can see each dot is a project, so it shows the benefit and impact score for each. And then once we have them plotted, we divided them into 5 management groups based on their relative benefits and impacts. Projects with low impact and any level of benefit are good choices to move forward first. So those are the projects in green and blue. Moderate impact projects here in yellow and orange are not a focus right away, but they may be advanced once the low impact projects are progressing. And then projects in red are not recommended right now for advancing because the impacts are just too great. So here's where those projects fall out when they're mapped. Since this was completed, this assessment, several green projects have been completed or are slated for restoration. They're all on public land. So Fur Island Farm and a number of projects down in the South Fork are underway or completed. And it's really important that we continue to monitor completed projects to understand and be able to communicate the outcomes over time. We really need to be able to understand whether projects are functioning optimally, and we have to be able to communicate how far we are toward those recovery goals of 2,700 acres and 1.35 million smolts. Now we're at another critical juncture. Low impact projects on private lands come next, lands projects, and we'll use this tool to support future conversations. So in closing, again, here's the organizations represented on the work group. A shout out to our funders, EPA, NOAA, RCO, and private donors. And then I included links to a couple of the products that we developed. One is the full 876-page report for anyone that wants all the dirty details. And then we also produced a 16-page summary report. And with that, I can take questions.
Great. Thanks so much, Jenny. Great talk. Jenna, do we have a question?
Yes, so first, if you wouldn't mind putting those links to the full report and the summary report into the chat. Some people were asking about that. And our comment and question is from Jason. It says, farm flood interests are often intertwined. It seems like the fish are at a competitive disadvantage in the scoring, ? Was there much pushback on that from the fishy folks?
You know, there wasn't there wasn't really the farm and in the Skagit there are a number of agreements and sort of background documents and that actually tie farm and fish together closely too. So there some of the objectives and indicators in the farm category actually kind of were tied to fish. So there was enough overlap between all of them, and we each got to define our own objectives and indicators. And so I didn't hear anything from the different folks involved about that or people we've talked to about the results.
Okay, thank you. There's more in the Q&A if you want to respond in text.
Okay, thanks.
Great, thanks again, Jenny. And Jenna, if you want to start sharing your screen, Jenna 𝗂𝗶𝗹𝗆𝗴 at the Skagit Drainage and Irrigation Districts Consortium. And Jenna is our last talk before the break. So let's give her our full attention. Her title is Partnerships Matter, Lessons Learned from the Skagit. You're in your notes. There you go. You got it all set. Take it away, Jenna. Looks great.
Okay, thanks. Thanks for having me. I'm going to build a little bit on Jenny's talk, and certainly, Sarah, your talk was interesting, and I suspect not a lot has changed since 2011. So the title of my talk is Partnership Matters. Part of this is building on my experience as a project manager when I worked at Fish and Wildlife. I'm now the executive director of the Drainage and Irrigation District Consortium, which is 12 special purpose districts in the Skagit dike drainage and irrigation districts. And that's primarily the Skagit Delta districts. So I think working through big projects, trust and respect matters. There are a lot of conflicting values across the landscape, and trust and respect are just critical to breaking down those barriers. And at the project level, my experience was that agreement on goals and outcomes of the project for all people involved was really important. So as Jenny alluded to, building trust and respect in the Skagit Delta has a much longer history than I have on this landscape. Dates back, I would guess, to the early 2000s with the Skagit Tribal Agricultural Accord, where groups of tribal members and key leadership from the agricultural community came together. There was also House Bill 1418 that was passed in the mid-2000s that was with the intention of advancing Chinook recovery on the landscape with a minimal impact to agriculture. Shortly thereafter was the Skagit Tide-Gate Fish Initiative, which was an agreement between the special purpose districts, the agricultural community, NOAA Fisheries, and WDFW. And this was again an attempt to solidify these partnerships with agreements. This has some, Tide-Gate Fish Initiative has some regulatory underpinnings as a way to advance and link Chinook recovery with drainage and infrastructure maintenance and repair. There was also the Farm Fish and Flood Initiative that came out of this, which was again an attempt to get people to the table to talk about how to advance mutually beneficial projects towards recovery. Out of that group came the Skagit HDM, which Jenny just talked about. And sort of concurrent with this was these large-scale estuary restoration projects. And that's where I'll spend the rest of the time in this talk, really digging down into the details at the project level. So the first project that I'd like to talk a little bit about is the Fisher Slough project. This was led by the Nature Conservancy. It was an agreement between the Nature Conservancy and private land owners in the Delta. So this was a conversion of private farmland. Key partners also included Skagit County Dike District 3. They were partners and ended up having to set back their dikes to allow this project to happen. And also Skagit Drainage and Irrigation District, some of the elements of the project required realignment and redesign of critical drainage infrastructure. And also Skagit County, they had easements in this project that had to be negotiated. There are a whole suite of other partners and funders, but I'm just going to focus on the key elements of this. So this was really a multi-benefit project. So there was conversion of farmland to estuary habitat. It's working great, my understanding, for juvenile Chinook rearing. It also had some key flood infrastructure updates. So the dikes that were set back were designed to core standards. They met the needs of Dike District 3 to continue to protect the farmland adjacent to the project from flooding. And then there was also some key drainage infrastructure elements of this. So there's a siphon at the project that had some elements built in to ensure that Drainage District 17 wasn't impacted. And there was also some work on the adjacent private farmland that wasn't restored to ensure that the seepage or inundation of the adjacent property didn't adversely affect the drainage in their field. I think there were tiles put in. And so it really was a process by which multiple organizations and individuals could bring their own particular values to the table. They were respected and then incorporated into the design. This project's been a huge success for all the key partners. Since this project was completed, both Dike District 3 and Drainage District 17 have taken over long-term operation and management of the infrastructure pieces of this project. So the second project that's near and dear to my heart, as many of you know, is the Fur Island Farm Restoration Project. It's got critical habitat, which is beautiful, provides habitat for Chinook recovery and just a suite of birds. And then also sort of the nitty-gritty critical infrastructure. And so this is where the significant project costs come and the significant partnerships between drainage and diking districts and habitat restoration. This is just some pictures of what the project looked the day that it was breached at the top, and then some of the construction photos of tide gates, dikes, and pump stations. So again, this was a partnership, and there were loads of people involved in this, and I don't want to minimize the importance of all of the organizations and individuals that made this project happen. But one of the key partnerships was the relationship between WDFW and Skagit County Dike Drainage and Irrigation District 22. And so the public land was used for the restoration, so it did have support from local ag interest groups. It was intended to minimize the impact of private farm owners, although private farmers were farming the area at the time, and it was part of the crop rotation system on Fur Island. But there were benefits to restoring public land. The area that was restored was about 131 acres, creating primarily estuary habitat for juvenile Chinook. It's part of the Chinook recovery plan, rated very high in the Skagit HDM project. There were benefits to the infrastructure. As Jenny mentioned, a lot of the marine dikes were built around 120 years ago. They're aging. There wasn't a lot of design manuals back in the late 1800s. And so the setback dike was designed using NRC standards, engineering standards, and a detailed analysis of coastal risk flooding. So this is when you set it back and you look at climate change, making sure that the district isn't inheriting a long-term liability problem. And then there were elements of drainage infrastructure that were incorporated to ensure that drainage wasn't impacted from the project. I have a different presentation on that, and it's fascinating, but changing ebb dynamics really does impact subtidal drainage if you're not careful about the way you're designing the project. So their tide gates and the pump station were incorporated into the final design based on some of that hydrodynamic modeling. So right from the beginning, there needed to be agreement on goals and outcomes. And this was sort of facilitated by what was known as the Landowner Agreement. And so this was an agreement that we started working on at 60% design. And it was a way to engage the diking district in a much higher level than just public review and comments. So this agreement was legal, it was binding, it was signed by WDFW and District 22. And it was really tightly linked to a monitoring and adaptive management plan. And so in advance of this landowner agreement, there was pre-project data collected, a whole suite of data, groundwater and surface water elevations. And then there was established numeric performance criteria to ensure that the project was meeting expectations. And I'm just going to focus on the partnership piece of these. There were many other adaptive management requirements related to habitat. So the key ones for the dike district were dike height, the width of the dike, erosion and settlement, and this sort of links into them reviewing and approving the design. There were a lot of criteria related to surface water elevations in the drainage system upstream of the project. And so the idea is you wouldn't want to impact offsite drainage by the project. And then also there were groundwater locations, and again, sort of monitoring this to ensure that the setback levy didn't affect groundwater outside the project footprint. Groundwater is a critical thing for farmers in the Delta. So this is just an example of how the data looked and what some of the, what this led to. So pump performance was one, dike performance and crest elevation, and then toe erosion. So as part of the design, we did dike settlement monitoring stations every 500 feet along the entire 1 mile of the setback levee. We plan to do the construction over 2 years. So the bulk of the levee was constructed in year 1 before the breach. The dike was allowed to settle between year 1 and year 2. And we monitored settlement relatively frequently over the course of that year. Towards the spring, at the end of that first year, we plotted the data. And what we noticed right away was that the settlement that happened over the course of that year was significantly greater than what was predicted from our geotechnical engineering evaluation. And the other significant thing we learned was that the settlement curves hadn't flattened out. And the risk there is that the settlement was still occurring. And what we had hoped for was that over the course of that year, you'd see settlement at the beginning, and then it would sort of flatten out, saying that most of the settlement has occurred. And so we made a design decision prior to year 2 construction that was to raise the dike an additional ½ foot to account for this sort of unanticipated settlement. Once that was done, the dike was finished, and then we breached later that year. And so this
1 minute, Jenna.
Okay, one example. The second example, and this is a map of just all the different locations where we collected pre-project and post-project surface water and groundwater. So this was not only water levels, but salinity. And then we worked a couple of different ways to try and plot pre-project and post-project information, presented it to the district to ensure that the project hadn't had any adverse impacts on adjacent private property drainage systems. So I think the takeaway really is that most of these restoration projects, particularly in the deltas, are actually really big infrastructure projects. There's high degrees of risk and liability associated with moving dikes and levees. They require really large investments in state and federal funding. And for these projects to be successful, I do believe that we need policies and funding mechanisms that are in place that support multiple benefits at the project scale. And one thing I learned for sure is that landowner agreements and adaptive management plans are really critical before construction, and that they're adequately funded so that you can address problems as they arise. So with that, I'll take a question or two if I have time. Thank you.
You do. Thanks so much, Jenna. Great talk.
Thanks.
All right, we've got one question from Paul. Did the district consortium you manage form in response to TFI-DFI issues? And if so, how has formation and existence of the consortium affected social political dynamics?
I mean, the simple answer is yes. There's a lot, when these districts formed in the 1800s, there weren't a lot of environmental regulations, there weren't a lot of agreements, there wasn't the complexities. And so that is part of, absolutely part of why the consortium formed. The 12 districts that are in the consortium are the 12 districts that have signed the TFI and DFI. But also there's just a need for infrastructure improvement, grant funding, and just organizational health. We're sort of at a transition. There's a lot of district commissioners that are in their 80s. We even had a district commissioner just retire. He was 94. And so how do you transfer that generational knowledge to the next generation, or even the generation in the 20s and 30s? I think it's shifting the dynamic, but we've only been in business for 2 years, so it's really way too early to know. But that's the hope, is that it leads to more collaboration.
Awesome. Thank you.
Great. Thanks so much, Jenna. And thank you to all the speakers this morning. A really great set of talks and really interesting questions rolling in. Awesome. I'll give you an introduction here. 𝗵𝗁𝗵𝗏 with the Snohomish Conservation District. And his title is, "Are you serious about salmon recovery in Puget Sound?" So take it away, Monty.
Great. Thank you, Jason. And thank you all for allowing me this opportunity to speak today. And just really appreciate the presentations up to this point, and looking forward to the ones later today and our discussions this afternoon. Yeah, so are you serious about salmon recovery in the Puget Sound? I know you all are. But I'd really like to take a deeper look if we could. Here's a beautiful picture of the 𝗂𝗃 Delta, and what it demonstrates to me is just that we have a complex world in which we live in, and that we're all trying to work within. And it's going to take a lot of different things to get us from here to there, to recovery goals, et cetera. So the question that I really wanted to raise, if we are serious about salmon recovery, we must engage private landowners at the community level. And we've heard numerous conversations about that yesterday, and conversations about it already this morning. And I think later this morning, we'll hear even more about the importance of engaging private landowners. Private landowners and that engagement is critical. There's a picture that was taken back in 2018 of an event. And the speaker that's there on the right-hand side is Rob Duff from the Governor Inslee's office, and he was the natural resource policy lead at the time. And I'll just dive into that in a little bit later. But really, the story begins for this picture and what I want to talk about back in 2010. And as you heard Mike Rastay talk about yesterday, is back in 2010, the Snohomish County Farm Bureau and other agricultural groups were really trying to stop as many restoration projects as they could, specifically projects like Lake Way Island and Smith Island. And they were suing and they were testifying in front of the Snohomish County Council on a weekly basis. They were down in Olympia trying to get legislation passed that would stop recovery projects. They were against the Snohomish Sustainable Land Strategy that Mike referenced yesterday. And then they were meeting monthly at their monthly board meetings, basically talking about and strategizing for ways to stop and or slow down and or just disrupt the salmon recovery process. And those meetings were toxic. Those meetings were very toxic. So in the fall of 2010, I started to attend those meetings on a monthly basis. And I can, you know, second Wednesday of every month from 7 o'clock to 9 o'clock at night, I would be attending those meetings. And I would attend those meetings in silence for the vast majority of the time, and was never really asked to talk or engage. However, things began to change in 2015. About 50 meetings later, they started to ask my opinion. But it took 50 meetings, you know, 100 hours plus, before I was asked for my opinion. And then in 2016, they started to really begin to shift and change their approach. And that was finally very much a relief and good to see. Then finally in the summer of 2016, they decided to host a farm to table event where they invited an equal number of agricultural representatives and an equal number of tribal salmon recovery restoration representatives. And for me, the goal of that meeting and that event were fairly simple. It's a willingness to engage and to show up and to participate in conversations with other people that you probably disagreed with. There'd be no yelling, screaming, or grandstanding. And if we could accomplish that on that first night, that was a success. And at the end, there was hopefully going to be a desire for future engagement. And that event, I think, and there are some of you that on this Zoom call that were in attendance, I think that was a huge success. It was such a success that the next morning or the next day on August 17th, I got a call from the governor's office asking why they were not invited. And so that to me was the beginning, at least in Snohomish County, of this more open dialogue with private landowners and a recognition that, hey, we need to be working together if we all want to be successful on the landscape. 2 years later, we had this event that you have here in front of you. And as you can see, and that event was called the Farm and Fish Come Together. It was hosted by the Tulalip Tribes, the Snohomish County Farm Bureau, and others, where they came together and invited electeds and others to have this conversation and to further the conversation. And Rob and the elected officials that were there, I think, came away with a clear understanding of the importance of landowner engagement. As I stated earlier, after our 50 meetings plus, obviously this takes a lot of time and effort, energy, and commitment to have these conversations and to continue this dialogue. However, I think it's worth it and potential significant benefits if we can go beyond the talk and the action. And I think you'll hear Jason Griffith talk about it a little bit today in his project. Maybe Lauren will dive into this a little bit as it relates to 𝗏𝗏. And then also, I think you saw ultimately with Smith Island, even though, as Mike said yesterday, it costs a lot of money to get to the end result. I think over time, we finally got to where we needed to be. So really what I want to drive toward today then also is this is only possible with funding, which doesn't exist today at the level needed. And so I really want to challenge us to think about if we're serious about salmon recovery, and I know everybody on this call is what do we need to do to go beyond where we are today to really advance salmon recovery? So I know, once again, I know you all are serious about recovery. So what can we all do? We must go beyond the individual projects. We must implement a wider array of projects. We must engage private landowners and the public. And this funding is critical. So I'll just conclude by saying, if we're serious about salmon recovery, we must seek funding for engagement of private landowners. And to me, that's a critical piece in what we need to do. We have capital funding available, but we need to dive down and get into operating funds with a lot more flexibility to allow us to really have the engagement and the interactions that we need. And you saw some of the work and already in just these presentations this morning and some of the conversations we had with Sarah, how important this social piece is of salmon recovery. And that concludes my presentation and open for questions.
Great, thanks so much, Monty. Jenna, how are we on questions?
There we go. Alan asks, were the tribes at the table?
Yes. So the tribes were at the table through the sustainable land strategy process. And I can get into that in a little bit more detail, which was back in 2010, ag representatives and tribal and restoration representatives came together. And so they were at that table. For those of you that know 𝗏𝗟𝗏𝗴𝘁𝗀 from the 𝗏𝗏𝗏𝗏 tribes, he's just an amazing human being and an amazing person to bring people together. And so, yeah, so they were at the table, as well as the 𝗏𝗏𝗏𝗏𝗏 tribe of Indians, the Shawnee was at the table as well. And this doesn't happen, right? Equally, right? These things don't happen if you don't have the tribes at the table as well. But I think we need to be all at the table, including the tribes and the restoration community and private landowners. But they were actively at the table.
Quite a few more questions rolling in, which is great. So Juliana asks, Monty, how did you get the invitation to come to the monthly meetings in the first place? I imagine that was a tough and critical first step.
Yeah, so I was working for the Conservation District, and at the time, I'd started with the Conservation District in February of 2010 after being on the board of directors for 25 years. So been involved with the Conservation District for almost 35 plus years. But back in 2010, they had at one of their monthly board meetings was criticizing the Conservation District and our funding and why we were involved with the sustainable land strategy and how could they do that and so on and so forth. So I went to their next meeting, their next monthly meeting, and to address any questions they had to their concerns with the Conservation Districts. There's crickets about the Conservation District, but I heard plenty about salmon recovery. And so I decided I'm going to continue to go to those meetings so the Conservation District doesn't get thrown under the bus again at another meeting. But then it became much more than that. It became, for me, obvious that I needed to actively engage with these folks. If I was serious about salmon recovery, then I needed to engage with them and be the conduit, a potential conduit between them and the salmon recovery world.
Mm-hmm.
So I wasn't necessarily invited. I went and just continued to come.
Oh, wonderful. Yeah. Okay, we got another one from Diane. Do you think additional funding for SLS would be a good venue for accessing private landowners?
I think SLS, but it goes, I think, much broader than that. I think it's trying to find flexible funding for not only SLS, but all of the other local groups that are going on, right? Within each county has various things going on. But then just others that are engaging with private landowners. And, you know, a lot of times that comes back to conservation districts because that's been our mandate for, you know, for in case of Snohomish Conservation District since 1941. But I think it's much broader than just conservation districts as well. And these local place-based groups, you know, ESRP, you know, RCO, trying to get funding in these other organizations that will be helpful.
Mm-hmm. Okay, and this kind of plays on that answer as well. A question from Paul: given the structures and dynamics of state and local governments, where do you think this community convening authority could live?
Where it could live?
Mm-hmm.
Yeah, so Paul's asked that question to me before. I don't know that I've ever had a really good answer to that question. I think it does going to go back to what I has said before is, I think it's going to depend on each local group as they come together, as to where it resides and where that, yeah, I think it really needs to start from the ground up at the local level with private landowners and other constituents and other interested parties. And then, you know, finding a place for it to reside. If it needs to reside within a state or federal agency, you know, my biased opinion is the Washington State Conservation Commission. And the reason for that is they already have funding that's operating dollars that are being pushed out today to local groups through the local conservation districts and through other means to help in this engagement process and to help with this community building. So that funding is there, but it's inadequate for us at the conservation district level. Once again, I'm retired, so I'm not representing the conservation district, but is at that level to be able to really engage as is needed.
I think that's all the time we have, but there's a couple more questions in the Q&A regarding to funding.
Great, thanks. I really appreciate it.
Thanks so much, Monty. And Emily, if you are out there, you can start sharing your screen. I see you there. Emily Howe is with the Nature Conservancy. And her talk today will be on zeroing in on food web function, a landscape connectivity viewpoint. Your screen looks great, Emily. Take it away.
Awesome. Hi, everyone. Yeah, so I'm going to talk about a different kind of connectivity, not one to people, but one down to the very bottom of the food web. So I am, right now, I'm an aquatic and estuarine ecologist working with the Nature Conservancy. And I'm going to show you sort of my 10-year retrospective on some food web work that I've been doing in estuarine deltas and restoration sites that really look at the detritus-based food web of these systems. So a little primer on detritus-based food webs. They are really what drives metabolism of nearshore communities and estuarine deltas, not only in Puget Sound, but also globally. So for example, suspension feeding mussels depend on detritus for anywhere between 11 to 88% of their dietary needs. And that's dependent on seasonality. So depending on the month of the year, they'll be more or less dependent on detritus, then they may shift to phytoplankton. So phytoplankton-based food webs or algal-based food webs are quite different than detritus, and they usually work in tandem together. But so, you know, algal systems, you get these pulses of algae and a phytoplankton bloom, and all of that is really very bioavailable and directly accessible for consumers. Detritus is a different story. So macrophytes, for example, about 45% of macrophyte production will go into the detrital pool, 10% of which is directly labile and enters into what we kind of consider the primary consumers, like copepods and amphipods and stuff, so like fish food. And the rest of it goes through a conditioning process in the microbial loop, so fungal processing and bacterial processing, and that kind of creates this like delectable frosting on the outside of your detrital particle that increases its nutritional content for the food web. But it's a slow process. It requires the retaining the detritus in the system for that conditioning to happen. But it's also a consistent process. So organisms can rely on detritus consistently throughout the year, whereas algal communities sort of bounce up and down in their availability. And so there's these punctuated periods of really high quality food and then it disappears. And so detritus kind of comes in and fills in the gaps. The amount of detritus has been shifting over time as a result of land use change. So here in Puget Sound, as a result of estuarine habitat area loss and nearshore community loss of other types of plants, we're looking at about a 450 megaton loss of detritus entering the system per year. And that's something that we've seen happening globally. So against this backdrop, we started kind of asking the questions of like, well, what are the mechanisms of food web connectivity in Puget Sound estuaries? And if we can sort of unravel the interplay between landscape ecology and food web ecology, maybe we'd be in this position to make restoration recommendations that will recover some of that loss, or at least provide better access to the detritus and the food resources that remain. So we built a project, Sally Simonstead and I, when I was at UW, kind of that sprang from the shoulders of a geology paper by 𝗵𝗂𝗧𝘄cie. So he was looking at constrained deltas worldwide and looking at what happens to their the plume as it hits the marine system. And so what he was showing is that when you get constrained deltas, constrained river systems, you get these jet-like plumes that have this fire hose effect. And the plume just sort of shoots off the edge of the ΔH shelf into deeper waters. And Eric Grossman did a nice job of describing that process happening in Puget Sound yesterday. And then you have unconstrained deltas where you still have a really nice tributary network. You have over channel flow into the marsh plain. You get these diffusive plumes that create this really nice hug of the freshwater lens in the sediment that kind of keeps everything right around the delta. And so we were wondering, well, what does that mean for food web connectivity and food web access for the benthic organisms and nearshore organisms that live in these areas? So we looked at a suite of different estuaries within Puget Sound with a gradient of different fluvial forcing, starting in 𝗏𝗏𝗧𝗄 Sound, which of course has no river system, then 𝗏𝗏𝗶𝗹𝗏 Bay, Samish, Port Susan, then on up to Skagit. And we placed transects of mussels and clams across the ecotones of these sites to look at, and then use stable isotopes to track their food web resources as you looked at them across space. And what we found was that for mussels, and as you increase fluvial forcing, so from Lopez Island over here to Skagit Bay, you decrease the amount of phytoplankton influence in dark blue, and you increase the amount of marsh. And that's true for both high flow period and low flow period. So you get increasing terrestrial connection with flow, so which means that river flow is really helping to force connectivity and push material across space. But when we looked at the clam diet, so these are benthic deposit feeding clams and 𝗏𝗏𝗧𝗏, so they feed right along the benthos, the surface of it. What we saw was a really different pattern. So we saw sort of a bell-shaped curve. So when you got to the highest fluvial forcing site, Skagit Bay, the diet of that bay looked much more similar to the sites we were looking at in Lopez, which meant we were seeing like there's a peak level of connectivity for these clams in terms of fluvial forcing, and then it drops back down and you get disconnect across space. And so what we were seeing is there's this interplay between freshwater discharge, flow velocity, and feeding mode of an organism. So freshwater discharge, tidal action, that's what helps move detritus around. But then flow velocity is what affects whether or not detritus is retained in the system to go through that conditioning process. And then depending on what kind of a feeder you are, you either have a kind of a clam view of the world, which is like stuff is passing by over my head and I can't get it because it's not being retained, or you have a mussel view of the world, which is I can grab anything I want as long as it's coming by. And so what this means for restoration implications is that when you have hydrologic alterations of levees and dams or distributary channel loss, you're going to see more food web disconnectivity as a result. In the same way that you see food web disconnectivity when there are major landscape changes, like a loss of marsh or a loss of an eelgrass bed. Hydrologic changes and ecosystem loss, they both can create different degrees of food web connections or disconnections. So we started looking at different types of restoration projects down in the Snoqualmie Delta with the help of Alex Gooley and Joseph 𝗶𝗶𝗏𝗏, who many early mornings let me through the gates. So thank you very much for that. And at this point in time, it was about 2010 or so. So the levees at the Nally Farm or Nally Island area had not yet been breached or removed. There was an old breach. So we had a nice experimental design where we had a natural marsh, a levee removal site that was quite young, and a levee breach. And here we use stable isotopes again to track the diets of mussels that we placed across sort of the interior and exterior of these sites. And what we found down there was that there were significant differences in the diets of the mussels in those three zones, that the diets really track seasonal organic matter availability. So in the spring, they keyed right into phytoplankton. Summer, they shifted to macroalgae, and in the winter, they really relied on that marsh detritus to kind of get them through the next spring. And when we looked at growth of the vessels, it really was explained and depended upon the whole suite, the full envelope of those organic matter sources, which to us means that that connectivity and the ecosystem adjacency of different types of organic material is really important to maintain estuarine species throughout the entirety of the year, not just really what we think of as the growing season. When we looked at the similarity of these diets across the different marsh types, we found that the very young restoration site, levee removal site, was much more similar to the natural marsh than it was to the levee breach site, or that the breach site was to the natural marsh. And so what this told us is that when you increase the permeability of these boundaries, you can kind of jumpstart or escalate the restoration trajectory compared to when you have a site that is less connected to the landscape. So all that work kind of led us to think about, okay, what are the main factors that are affecting gradients of food web connectivity as we see them on the landscape? And that includes the strength of the physical forces, like the tidal amplitude, as well as the river flow, the permeability of the boundaries of the ecosystems you're working with, the organism's life history and feeding life history itself, ecosystem adjacency to one another, and the area of the source. So do you actually even have a marsh to produce detritus? Which brings me to more recent work that I've been doing down in the Sacramento-San Joaquin Delta with colleagues from USGS and the San Francisco Estuary Institute. So here we've been looking at the human appropriation of net primary productivity and what that means at a landscape scale. And so this is all built on the shoulders of a really remarkable project by SFEI, the San Francisco Estuary Institute. They did a spatial historical reconstruction map of what the uncolonized delta once looked like. And so they were able to spatially map out the different estuarine plant communities throughout the Sacramento-San Joaquin Delta. And they were able to do that in a dry year and also in a wet year. So we can look at the difference in connectivity over time. And then you can compare those to what we have in the modern system. So what we did as a group was to then calculate the net primary productivity of each of those plant community types, so we could reconstruct the historical contribution of the delta to detritus-based food webs, and compare it historically and also across dry years and wet years. And what we found is that aerial loss is not proportional to functional loss. So here in Puget Sound, we have also seen a 77% loss of our wetlands, same as down in Sacramento. That has translated down there to a 94% loss of ecosystem net primary production, an 89% loss of net primary productivity flow to herbivores, and 94% loss of detrital production. So the base of the food web here is taking a big hit. And there's also been a qualitative shift in the type of primary production that's available to the system. So it went from a predominantly marsh-based detritus system to one that's more dependent upon aquatic plants, phytoplankton, and attached microalgae. So this affects the timing and the accessibility of these food resources for the organisms as well. And then you can look at our restoration plans and say, okay, well, these are where we want to do restoration. Now we can calculate, well, that would be, an increase of 12% of NPV, but more importantly, a rebalancing of the food web organic matter portfolio, which we've now seen, species that are native to the system rely on this particular balance. So when I think about restoration and adaptation for Puget Sound estuaries, and I'm particularly focused right now at the Nature Conservancy on our Port Susan Bay site and adaptive management there, I'm really thinking about how can we use process-based restoration to rebalance the historical suite of organic matter sources in the same way that we're trying to rebalance the historical sort of portfolio of habitat types for Chinook salmon as they move down the estuary. And I'm also thinking about how we can create connectivity to those sources of material for both motile, but also for non-motile species. And Roger Fuller will talk a whole lot more about this project at the end of the day. So thanks.
Awesome, Emily. Great talk. And Jenna, do we have any questions rolling in?
I don't see any yet.
We'll give
my applauding to work, my clapping, but Emily, that was awesome.
Virtual applause.
Thanks much.
if folks have questions for Emily, oh, here's some rolling in.
Yep. All right. Oops. Stephanie asks, can you direct me to where I can find specific productivities for different habitat types?
Yes, so this paper, the San Francisco one, is like in its last set of revisions right now. So those will be published soon. So I'm not sure that I can share those right now. I have to check with the giant group. But I'll let the group know when that paper comes out.
Okay, great. Let's see, Paul asks, who did the cool ecosystem rendering in the Bay Area? Artist for hire, question mark?
This is all done through the San Francisco Estuary Institute, which I encourage you all to go check out their websites. They have phenomenal, renderings and graphics. It's kind of one of their strong suits, I would say. So they're a really fun group to work with when you need visuals. So I can't remember who did that particular one, but it was real handy to have when we needed to do a graphical abstract for the paper submission. But yeah, San Francisco Estuary Institute is the group.
Great, thank you.
All right, thanks so much, Emily. Let's move on to Lauren. Lauren, if you could start sharing your screen, please. Lauren Brokaw is with WDFW, and the title of Lauren's talk is Lost in Translation, Closing the Gap Between Stakeholders and Scientists. Your slide is looking great, Lauren. And,
all right.
Yep.
Thank you very much. Let's see, I'll try to get into presentation mode here. There we go. So hi, everyone. Thank you so much for having me. My name's Lauren Brokaw. I'm a project coordinator with Washington Department of Fish and Wildlife. Very lucky I have a great job in which I get to manage projects on WDFW-owned lands. And some of those projects are estuary projects that we're talking about today. And so I consider myself a practitioner. Today's topic will be a topic I've never given a presentation on before, so I'm a little nervous about it, but hopefully it goes well. And it has to do with, as a practitioner, I oftentimes find myself in this role of translating the science from scientists to stakeholders. And big caveat, I'm definitely not a social scientist, and I'm also not a nearshore scientist in the sense that I don't do research and publish papers, but I am often in this position where I talk an awful lot about it. And so a typical project that I work on is shown here. This is Lepoi Island, and this is what that site looked like for about 100 years as farmland. And in the community's memory, this is what the site always looked like, is a farmed dry site. And in the time that Department of Fish and Wildlife managed that site, there were all sorts of recreational opportunities people took advantage of. It was a very popular place for people to watch birds. It was well known as a place to reliably see owls, as shown here. And the state also released pheasants on the property, and so it also became a very popular hunting site. And then someone like me comes along and starts talking about concepts that would change the use of that land and flood it. And it was a long drawn out process of about 20 years of talking about a project, and eventually it was implemented. And water poured into the site. And on this 250 acres, the site went from looking something like this to something like that. And depending on who you are and what your values are, that could be a cause for celebration, or you could also see this as being a travesty. And as someone whose name and phone number is on the sign of the project site, I get phone calls and communicate with people on all different sides of that spectrum. And so I've never really put a lot of thought into this until recently. And when I talk with folks, I think everyone falls somewhere on this meter as we're talking about a project. There are people that oppose it, people that support it, and folks that are somewhere in the middle. And so there are certainly people that fall into the red category. And I hear from these folks a lot, and they're, pretty entrenched in their opposition. This likely isn't the first project of its type that they have been involved with. I found that no matter what we do or say, there's a pretty low chance that these folks will change their opinions of the project. They often have a direct stake in that specific property. An example could be someone who uses the site for recreation and they see their stake as being lost with the project. And again, these people are motivated to want to talk to us, so we hear from them a lot, but I think we probably overestimate their abundance because we hear from them at a higher rate than other folks. There are other people on the opposite end of the spectrum that fully support these projects. This is another group that we hear from a lot. They attend our presentations, and we probably overestimate their abundance as well because they're motivated to support us, and they'll continue supporting us unless we really screw something up. And then there's a big category of people that I think fall somewhere in the middle. They oftentimes have little or no experience with these types of projects, and they need additional information for them to really form their opinions about these projects. They usually don't perceive themselves as having a direct stake in the project, in a project, and they're open to moving one way or the other on this scale, and that depends on kind of the new information they get, where they get it, what it consists of, and so they're vulnerable to moving in one direction or the other. And I think this group is really big, but we rarely hear from this group, and so I think we probably underestimate their abundance. And so what I believe is true is that the way we communicate about these projects impacts which direction this group of people in the middle will go. Will they become more green or more red? And there are two main phases of a project in which we're communicating with people. One is when a project is at its concept phase, when we're doing planning and design. We tend to do a lot of outreach to folks, getting their feedback on projects. Another opportunity to talk with these folks is after a project is implemented on the landscape and people can see it and are curious about how the project is working. And so why does this matter? I think it matters for a lot of different reasons, but some that I've highlighted here are that if we do a poor job, we've known from experience that this makes projects harder, they take longer and end up being more expensive, because the more people who oppose a project, the higher chances that these folks can organize and appeal projects through the permit process, hire lawyers, et cetera. With a wider group of people that oppose a project, there's also a greater chance that they'll be able to persuade others to oppose projects as well. If we do a good job at communicating, projects tend to be easier, they move quicker, and there's often more funding available to implement them. And reasons for that, I think, is because the more supporters we have, the more those folks are out talking to other people and persuading people to support the project. And in the end, I think that could lend for additional funding through our restoration programs. I think this matters because, Puget Sound recovery is such a huge endeavor, and no single project in the landscape will achieve that goal alone, and we need to continue to build momentum to continue to reach our targets. And in these communities, there's always going to be a next project. So when I'm managing a project, I like to keep in mind that the job I do at communicating with that community will likely have impacts on the next project that comes up on that community. And regardless if that's WDFW managing that project or another one of our partners, we really want that project to be successful. So now I'll talk about some of the lessons I've learned. And that's just, coming from me, a practitioner, talking with a number of folks. So as we're scoping and conceptualizing projects, I think most people that are curious and wanting to talk about the projects are really just trying to figure out how the project intersects with their values. And what I've found is, different people have different experiences with these projects. Some may know next to nothing. And so it's really important to just kind of meet people where they are and understand their values. It's also really important to not overpromise results. I tend to be a very optimistic person, and so I've been guilty of doing this in the past and have learned the hard way. And also, we've heard a lot of talks over the last couple of days about predictive modeling of projects. And the information that comes out of those predictive models, I've found to be really, really useful in having these conversations with people and helping them visualize how a project may end up looking. I've also learned that folks that fall into the red category, although conversations with them are sometimes uncomfortable and challenging, it's really important that we listen to these folks because really, rarely is anybody, all the way right or all the way wrong. And there's always a chance of learning something from somebody with a different point of view that in some cases can end up making your project better. And after a project is implemented on the landscape, I found that it's really tempting for me to just go on to the next project and forget about the one that was recently implemented. But what I found is, the finish line of a project is definitely not when the construction equipment leaves the site. Adaptive management and monitoring is so important and takes a lot of effort. And also being able to demonstrate results to our stakeholders is very important for the next suite of projects that we have planned on the landscape. And so it's important that we speak to metrics that are important to people, and those metrics aren't always exactly what we think they are. Obviously, ecological, biological outcomes are important, and people want to know, did the projects turn out the way we thought they would in terms of fish using them, birds using them, vegetation, et cetera. But there's also other metrics that are important, such as we heard Jenna talk about, infrastructure. These are also large infrastructure projects. So how is that infrastructure working? Also, these big projects also come with changes of recreation. And so people's experiences and how that recreation changes is important as well. And what I've really learned is practitioners like me come and go from projects, but projects remain on the landscape for a really long time, and communities that we build them in have very long memories.
Lauren, you're at 2 minutes.
Okay, thank you. And so the last point I want to make is that nearshore science is really at the foundation of the communications people like me have with stakeholders. The pre-project predicted outcomes are really important in that we can help people visualize what a project might look like, and that helps them decide where they fall on that scale of green, yellow, or red. And then it's also really important and sometimes overlooked that following up with post-project results really closes the loop with people and helps and will end up helping the next project proposed in that community. And so when I started working in a position like this, I didn't know that translation of this science to stakeholders would be such an important part of the job, but I really have found that it is. And framing that science to people is something that just through trial and error, I've had to learn over time. And sometimes just really, really simple things can make all the difference, such as photo evidence. Just a week or two ago, I had a presentation to Skagit Audubon in the evening. And that morning, Skagit River Systems Cooperative was at Lepway Island sampling fish. And they were able to capture a number of Chinook and chum salmon and sent me photos of those fish being captured on the site. And it's hard to tell through Zoom meetings how your presentation is going while you're giving it, but I could really tell that those photos of salmon on the site that very day made a very big impact with those folks. And hopefully that will generate more support for projects in the future, things like that. So that said, that's my last slide. And if I have time, I'm happy to take questions.
Thanks, Lauren. Great talk. And you won the Exactly on Time award. The beaver just went at 12 minutes. So yeah, nicely done. Jenna, how are we with questions?
I'm not seeing any questions quite yet. Some comments of just great presentation. I'll just go ahead and read one. Sarah says, I'm loving your talk. I see it as a really clear translation of the insights I've had as an environmental anthropologist into concrete principles for practitioners. And comments like that as well. So good job.
Yeah, thank you. We've been talking offline of wanting to invite her to our Fish and Wildlife office to talk more about her presentation. So,
okay, Great. So the next talk is, well, I think Daniel Elephant is giving it, but there's a few authors here. And so this is with ESA and other consultants listed here in the Snohomish Conservation District. And the title is Studies on the Impacts of Sea Level Rise on Agricultural Viability Inform Future Estuary Planning. So take it away.
So I am going to start us off and then pass it to Dan. My name is Cindy Dittbrenner. I was formerly with the Snohomish Conservation District until this last summer and then recently moved to the East Coast. So much of what we're presenting today, I was the lead on, but now have passed the torch to Bennett LaFond, who's at the district, who will also be wrapping things up at the end. And then Dan Elephant is now at ESA. This work was actually done under Cardno's name, but he's now at ESA. So have to give them a little shout out, but we'll all be kind of running through a few slides. I'm just going to give the intro and then pass it to him to talk about technical stuff that we did. Let me see if this works here. Great. Oh, here we go. Okay. So in the Snohomish and Stillaguamish River systems in Snohomish County, we have what's called the Sustainable Land Strategy. And that is our table that we've set to bring together people from the fish farm and flood perspectives. And it had been going on for quite a few years, 8 years or so, when we started talking about the fact that we were having trouble getting community support for some of these fish projects because it was taking ag land out of production. And so the Conservation District and partners identified the need for an agriculture plan. We thought if we have an ag plan that outlines what the needs of agriculture are, what their infrastructure needs are, what their priority land is, then that would better help us represent ag at this table. And then we could better develop these multi-benefit project packages and advance not only ag, but also salmon recovery projects with more community support. So that's what we're going to talk about today, these studies that were done under this lens of the Agriculture Resilience Plan that the Conservation District did, but we're finding that that information is really beneficial for just all sorts of multi-benefit floodplain planning efforts. So what the Agriculture Resilience Plan is several different components, and we're only going to talk about two today, the ones with arrow there. So the impact assessment is the work we did looking at the impacts of climate change and flooding and drought on agriculture resilience in our county. And then that resulted in us creating these reach summaries that are very location specific with priorities for farmers. The two pieces I'm not going to talk about, but if you have questions, feel free to contact me, are these on-farm resilience practices, which is different techniques that farmers can do mostly to be resilient against drought, but also other things like flooding. And then farmland protection or preservation piece where we prioritized ag land in our county. I will state that this effort took 3 years and was a huge community engagement effort. Other speakers have talked about the importance of stakeholder and landowner engagement. We wanted the farming community to be behind this plan and feel like it was theirs and we were representing their needs. So we had a steering committee of 9 farmers guide this throughout the 3 years. We did a photo voice project, which you can learn more about on our website if you're interested, where we had farmers took pictures representing their needs. We ended up having about 8 community meetings. I say about because there were several smaller meetings as well, where we went over the results of these studies with farmers and developed these, their needs, the list of needs and projects that they came up with. So the reach summaries, then we have 11 in total. This is the Stillaguamish River. So this one's broken up into 1, 2, 3, 4 reaches here. 2 are the drainage districts and others are just delineations we made based on the landscape and farmer needs. And then in the Snohomish, there's another set of them, largely based off of the boundaries of the Daikin and drainage districts. So each of these reach summaries describes what impacts we expect to see, what are the needs, what's the current infrastructure, and then a list of projects or needs that each reach has identified, the farmers have identified. Roll all of those things that we heard up into the countywide priorities, and most of what you'll see in those reach summaries are these 5 things. Protection from floods, especially with increased flooding, access to irrigation water, especially with more droughts, improvement to drainage infrastructure, Sea level rise, you'll hear, is impacting that. Assistance building resilience to drought. And then what is this bottom one? Conservation of farmland. So I'm going to pass it to Dan here with the impacts assessment. The questions we asked for this are, what are the biggest environmental challenges for our ag community and how are they expected to change into the future? We couldn't just create a plan based on what farmers said here and now. We wanted some science behind it so that they could make informed decisions. And one of the first things we did was a groundwater analysis, because we knew that the level of the groundwater in much of our farms, especially near the estuary, was impacting the farmers' ability to get out on their land in the spring. And so we wanted to know if that's determining the length of the growing season, then what impact might sea level rise have on that? So Dan, I'll pass it to you.
Okay, hope folks can hear me. And next slide, please. So we installed, that's a GeoPro. We installed, shallow groundwater wells. And I'm gonna, in the interest of saving time here, just kind of jump right into results. This is largely based on an empirical analysis of well data, both salinity and water level. Here for the 𝗂𝗂𝗶𝗹𝗆𝗂𝗵, we also did this for the 𝗂𝗃𝗔. This is an example of spring crop cultivation delays. And we did this for out to the year 2100 for both climate change scenarios, RCP 8.5 and RCP 4.5. And so what you see here is a larger crop delay to the west here, closer to the ocean boundary, and a less crop delay as in accessible fields to your right here on the east side of the flood control district. So this is 2050. Next slide, please. And then 2080 for RCP 8.5. And next slide, please. And 2100. So it goes from a crop delay of about a week or two up to delays of up to 5 weeks or so. So sort of from 2 to 5 weeks of delay on Florence Island, and then in the middle of the 𝗂𝗂𝗶𝗃 flood control district, delays as much as 3 weeks, maybe 4 weeks at RCP 8.5. Next slide, please. For 𝗂𝗏 Island, we took a little different approach. Again, this is based on empirical data from Smith Island, Marshlands, flood control district, well data sets. We did groundwater ponding. So this is groundwater ponding now. I guess sort of blues would be standing water currently. And we calibrated this on the site with LiDAR images and available aerial photography to show that we have the inundation currently modeled correctly. And then next slide, please. Here's ponding, groundwater ponding in 2050. Next slide, please. 2080 and 2100. Folks might notice the graded out areas. That's where the topography of 𝗂𝗏 Island and the LiDAR was catching vegetation top. So we had to grade those areas out. But you can see that ponding changes from, on the order of kind of 0 to 1s to areas, certainly areas of 4 feet, 2 to 4 feet, simply driven by flow, underflow. Next slide, please. And then the last step was an empirical analysis, an empirical model of salinity, threshold salinity intrusion. We used 3 millisiemens a centimeter as our threshold for sort of crop effects. That's based on analysis of crops that are productive in these areas, beet, things like this. So what we see here is, on the left, sort of current conditions, and then an intrusion threshold of 3 millisiemens a centimeter, proceeding to the right here to the east as we move into the year 2100. Next slide, please. Or spatially distributed. Again, this is based on empirical data sets for along 𝗏𝗏𝗡, along the flood control district, and also Lepwe Island and Lower Camino Island. Here's 2020, 2050, next slide, 2080, and 2100. in the interest of time, I think I will let Bennett take it from here. Next slide, please. Thank you.
Yeah, so along with the studies that Dan was talking about, we worked with the UW Climate Impacts Group to develop a future flood impacts tool, building on something that TNC had already created. And what this gives us here is that we have flood depths for 2, 10, 25, and 100-year floods in the current, in 2050s and in the 2080s. And you can look through this tool a little bit more on the website below. Next slide.
Bennett, you're at 2 minutes.
Great. So in order to move forward with priorities identified in the Ag Resilience Plan, we formed 2 integration teams, one for the Snohomish and one for the 𝗏𝗏 watershed, with this idea of bringing together farm, fish, and flood interest to find areas of collaboration and to vet projects and build these multi-benefit project packages. Next slide. Working with farmers, I want to take a moment to highlight our work in Drainage Improvement District 13. This is one of the many reaches of the river where we use the information we gathered to work with stakeholders to identify priorities for ag resilience into the future and to develop some of these projects that we're developing with the ITs as well. And in the summary for this reach, as we developed the Ag Resilience Plan, what farmers really talked about and what they really focused on was this need for better drainage and for better drainage into the future as a top priority. Next slide. So here we're looking at one of the same tools that Dan mentioned. This is for the Snohomish. Previously, we were looking at the 𝗏𝗏. And what this shows is the delay in planting for farmers to get their crops in the field. And you can see here that by 2050, we're already getting up to a 3-week delay in a lot of areas in Diking District 13. Next slide. And by 2100, we're seeing over a 5-week delay in most of the district. This is something where we were engaging farmers with, as we talked about. Next slide. So here we took that flood prediction tool, and you can see in current times there's pretty minimal flooding in a 10-year flood event. Next slide. But that by the year 2050, we're seeing some levee overtopping. Next slide. And that by 2100 or 2080, we're seeing significant levee overtopping, flood depths of up to 20 feet in some areas, and a lot of flood damages. Next slide. So we took all those tools to landowners and used them to discuss, as well as other information from the impacts assessment that Cardno and Dan were carrying out, and developed this plan to split some of the agricultural drainage systems and fish systems in DD13 to help provide some solutions for farmers in the area. And basically what this means is that we're getting an improved ease of maintenance with in the drainage ditches by keeping fish out of them. We're keeping fish out of poor habitat, and we're getting this upstream and downstream reconnection, hopefully, to bring in some fish habitat to this red area that you see, to increase the flood storage and to catch some of the hill slope runoff to keep some of the water out of the farmland. Getting this this mutually beneficial multi-benefit project. And with that, I'll open it up to questions.
Great. Thank you so much to the 3 of you. That was a great combination of effort there. Jenna, how are we with questions?
We've got a question. John asks, what would improved drainage even look like for farmland adjacent to coastal dikes as sea level rises?
I can take a quick hit at that. Specific, you got to go straight to each kind of individual diking district and each individual site. One of the reasons we identified DD13 is there's an opportunity to isolate hill slope drainage from the farm system itself and take the hill slope inputs and put that into perhaps DD6 and even and certainly into Swan Trail Slough. So that's an example of one place where we could reduce flows. That project would also move the location of the pumps. So the pumps are only sucking away at the ag drainage system and not the tidal or the hill slope inputs. So we're involved in modeling all of that right now. It's kind of a big discussion, but that's just one example of how we might improve some ag and balance that with a salmon project.
Yeah, and similarly, that increased ability to maintain ditches is really important. Right now, just in the fields, a lot of those ditches, it's been a while since they've been able to maintain them because there's fish in those systems that make permitting really challenging and really slow down the process and the frequency of ditch maintenance.
So we're saying that there's not a lot you can do about saltwater intrusion into groundwater, though.
Mm-hmm.
Can't pump that out.
No.
Yeah, we found that within about 1,000 to 2,000 perpendicular feet to the ocean boundary, the salinity intrusion is a big deal. But somewhere like DD13, where you're miles away, salinity intrusion might not be a big deal. So if you increase pumping, you might not pull as much salinity up as, say, if you increase pumping on a place like Florence Island, you would certainly pull the interface up.
Okay, thank you. And you've got a great question from Eric in the chat, but we need to move on to the next presentation.
Great, thanks to all of you again. And moving on, Jason, if you want to start sharing your screen, I know I've been looking forward to Jason's talk for a while because of the title. I always thought I was the dumbest Jason in the room, but maybe Jason Griffith has something to say about that. Jason is from the 𝗗𝗃 tribe, talking about the benefits of being the dumbest in the room. So take it away, Jason.
Yeah, let me start the slideshow here. All right, does everyone see that?
Looks great.
Let's see if I can get a laser pointer going. Wow, this is great. Yeah, so I might be the dumbest, but we'll see. There's a lot of smart people in this room today, and you know, I have to admit that probably in the spirit of intellectual equity, you have me today because there's been lots of really great talks. But you know, I have to admit, when I put this title together a while back, I thought it was clever and funny, but now I think it might just be dumb. But anyway, we're going to go on. I'm Jason Griffith. I'm the acting environmental program manager at the 𝗗𝗃 tribe, and I'm going to talk about some lessons learned from a project you can see here. This is the 𝗬𝗎𝗶 project at the mouth of the old 𝗗𝗃 channel across from Stanwood. And 𝗬𝗎𝗶 was a tribal chief who lived in the area in the 1800s, and so that's why it's named after him. So let me see if I can advance. Why is it not going? Oh, there we go. Okay. So just to kind of orient you where we are in Puget Sound. So here's Washington State. 𝗗𝗃 is up in mid-north Puget Sound. 𝗗𝗃 watershed. 𝗬𝗎𝗶 project is down here at the mouth of the old channel. You can see here the old 𝗗𝗃 channel wraps around the site. Some goes out to West Pass and South Skagit Bay, some down to South Pass and Port Susan. So let me see here. There we go. The size of the site's about 88 acres. It was diked for a really long time, over 100 years. For the project, we removed over a mile of levee, and we built a small setback levee down here to protect the rest of Florence Island. We dug a lot of tidal channels. So we dug over 3 miles of tidal channel on the site. You can kind of see it here. There's 7 tidal channel outlets around the site. And there's this center kind of dividing berm that I'll talk about in a little bit as well. We removed about 43,000 yards of material. And from start to finish, including acquiring the land and doing all the work, it was a little over 2 million. There's significant infrastructure in this area. The city of Stanwood is right across. The wastewater outfall is just upstream. There's ag lands down here and Florence Island. So there's a lot to work around. The work was paid for from the usual suspects, ESRP, coastal wetlands from U.S. Fish and Wildlife Service, Surf Board, floodplains by design. So one of the benefits, so going back to the title, if you're the dumbest in the room, and dumbest is really kind of, I took artistic license, really the least experienced, maybe the least knowledgeable. With the 𝗬𝗎𝗶 project, we had assembled a dream team of folks. And so you have folks like Dan Elephant, who you just heard from, and Sky Miller, formerly with Cardno, now with ESA, doing the design work. They were assisted by Dr. Greg Hood here, who you heard from, I think, yesterday. He did the channel kind of conceptual design that Dan turned into the plans and Sky turned into the plans. Then you had Trimax Construction. So Todd Snyder here is one of the principals. He was assisted with John Nichols here, who we refer to as the Michael Jordan of excavator operators. He could do things with a track hoe that none of us had ever seen before. So it was super fun. And the pressure was off me. The pressure was on these guys, but there were, ample stakeholder concerns, and they can be addressed by those that are more credible than myself. And so that's one of the benefits of being the least experienced person or the dumbest in the room. And then these guys had been around tidal wetland projects before, so they knew what the potential legal challenges could be when you're restoring lands and working around drainage infrastructure and dikes and that sort of thing. So they were really aware of what we needed to watch out for. And then when things go sideways, no one looks to you to fix anything, because they're like, well, forget Jason, like, let's talk to these other guys. They know what to do. And so the pressure was off, and that was a benefit. Another benefit from coming into a project and not having a lot of experience like myself with this project was that you can learn from history and not your own mistakes. And in particular, from other projects these guys have been involved with over the years, they stress that we need to document the existing drainage and flood infrastructure performance. So for example, here, what's the levee condition on the surrounding lands? How is the drainage working? This is a tide gate and a ditch system that's full of sediment and not working that well. This is the old 𝗏𝗏 channel. Is it shoaling already? What's the bathymetry like in there? What are the dike top elevations around the site? That sort of stuff. So they did a really good job of identifying how things were working. The second, and you're going to hear a lot about you can learn from history, because I think that there's been enough projects now that there is some history to learn from. And so one of the things is, the tendency I think is to try and design like a really, 100-year levee, or design for sea level rise or whatever. Here's the setback levee we constructed. And Sky and Dan both brought up like, well, you don't necessarily have to have the best levee. It just has to be better than the other levees that are going to fail first. And so we looked around Florence Island and kind of looked at how the condition and how high they were. And so they designed this levee to be the last one standing, basically. And then the other thing we had to deal with was a pipeline that ran under the site that brought vegetable processing waste out to Florence Island here, where it was spread on the fields for irrigation. So we had to protect that with this berm so that these tidal channels didn't cut across there. So you kind of have to look at your site and design for that site, not necessarily what you'd want in a perfect world. And then another thing that they've learned over the years is to use tracked equipment whenever possible. So, it's more expensive, but we didn't give, the contractor really any choice in our RFP. We put that whoever was successful would use tracked equipment, and then that simplifies planning hauling routes, compaction on the site, getting things stuck, all that sort of stuff. These sites get really soupy after a rain often, and especially when the tides start coming in and out, and you can get in trouble real quick. And then I think we've heard a lot about this last couple of days, but really digging as many channels and outlets as you think are appropriate and feasible. And really for that, you need a channel allometry, a landscape allometry model, something like Greg's developed for the Skagit and 𝗏𝗏 and other watersheds. So if you don't have that for your area, I would encourage you to hire someone to produce it, because it really helped us design like these primary channels, secondary channels, and tertiary channels on the site. Again, we dug 3+ miles of channel, and it really helped jumpstart the site and get kind of a quiescent environment there for seed settlement for the marsh plants, and it's doing really well. Another benefit, or another part of benefit number 2, learning from history and not your own mistakes. The cheapest option isn't always in the long run. So I think everyone has heard that these projects are quite, or can be quite contentious. You're dealing with drainage and infrastructure and flood protection infrastructure that's critical to surrounding land uses. In our early discussions with the flood control district in the 𝗏𝗏, they were not really happy with us modifying the existing levee structure of Florence Island. And so in those negotiations, it came out that, well, if we produce, or if we incorporate this flood structure in the setback levee, which is basically a giant series of flap gates, that if this is the inside, the project site's over here, this is inside Florence Island. If Florence Island gets flooded in a large dike topping event, these flap gates over here will allow Florence Island to drain much quicker than through the existing tie gate infrastructure. And so this was something we designed into the project. It's good for fish too, in the sense that fish get stranded in the fields after big floods. But really it helps the drainage of the surrounding neighbors and makes them less likely to oppose the project. And so we did that, and it really smoothed things out for implementation. And lastly, if you are one of the most, I guess, intellectually challenged or least experienced people in the room, things will probably be okay, because all of us are not really that dumb, really. So, I mean, we got a smart group of people here. So if you're the least smart person in the room, chances are it's going to turn out just fine. It's probably going to be on time. It's probably going to be on budget. Probably not going to have a lot of change orders. Probably no lawsuits. It's going to be built per plan, and the fish and the birds will love it. These photos are all taken post-project out there at 𝗬𝗏. So this area right here was a spinach field 3 years before this photo was taken. And so this is one of those main channels that we dug. It looks pretty good to your eye when you're out there. It doesn't look like something that's only been there for a few years. This is a net full of sub-yearling Chinook that we pulled out of this channel. Here's some folks counting fish on the edge of the channel. Again, this was all a spinach field a few years before. And here's our some of our crew getting nice and muddy out there. We're going to have results from the fish and bird monitoring coming out in the next couple of years. It's in process right now. SRSC is one of our main partners, along with the Gary Slater, and I'm trying to remember Gary's affiliation, if it's a Ecosystems Institute, I think. Anyway, he talked also, but Gary and others are doing bird work, including our biologists here at the Stiligwamish tribe. So I probably don't have much more, because I want to have lots of time for you guys to ask questions. So I kind of try to just summarize things from the practitioner standpoint of a big project like this, and some of the things that I learned through it. So hopefully it was helpful for you. And if you're going to do a big project like this, I think Lauren's talk is a good companion to this, because that whole side of it I didn't really touch on, about talking with stakeholders and getting their concerns, their legitimate concerns addressed. So a lot of this that I talked about came out of those conversations. So I think that is all.
Great. Thanks so much, Jason. I feel smarter already. Jenna, do we have any questions rolling in yet?
No, there aren't any questions yet. Feel free to add them to the Q&A. I would just say great photos.
Oh, thanks. Yeah. Yeah, this was supposed to be kind of like, an intellectual breather for everybody. So just nice photos, not a lot of text, no big words. So just, you guys have almost made it through 2 days. You're doing really well. I mean, there's a lot of information here.
While we're waiting for a question or two, hopefully for people to type in, Roger, you could start sharing your screen to ease that transition.
Okay, we have one from Brian. It says, was this the project with a drone survey that showed the work?
Sorry, what's the question?
Was this the project with a drone survey that showed the work? I'm not sure what that's referring to. Follow-up is that was cool.
So there are some drone photos that Dan, when he was at Cardno, produced. And so those are the ones, the big overview ones that are like at the front and end of the presentation. But maybe I'm not quite understanding the question, but anyway.
I'm not sure if I am either. One comment from Tracy is great presentation, Jason. Definitely not the dumbest in the room. I would second that. I'm sure we'll get a whole bunch here in the next minute when we move on to the next person.
That's fine. I can answer them in the chat and in the Q&A.
Okay, thank you.
All right, thanks again, Jason. Great talk. And let's move on to Roger Fuller. And Roger is 𝗂𝗶𝗶𝗹𝗶𝘀 National Estuarine Research Reserve there, and title is Food Web Surprises: How Restoration Design Can Affect Productivity, aka How to Avoid Killer Moths. So take it away, Roger.
All right, thanks a lot, and thanks everybody for hanging on to the very bitter end of the Delta talks. There's been some great talks, and Jason, I really appreciated yours. I'm going to talk about another project on the 𝗏𝗏 Estuary, the Nature Conservancy project, a dike setback project that took place in 2012 and on 150 acres at the mouth of the river. And I just want to clarify at the beginning here, the monitoring and research work that I did on this, I did not while I was with the Padilla Bay National Reserve, but with Western Washington University. And also this project is one that I actually initiated way back in about 2002 in terms of the preliminary design when I was working for the Nature Conservancy at that time. So first, I just want to start with a quick little story of change to kind of illustrate what I'm going to talk about in this talk. And so this is the restoration site in 2006 before restoration. That in the few years before taking out the dike, the site developed a large, very lush, head tall, brackish marsh that was non-tidal because of the dike, but it was very productive, as you can see. And just for a frame of reference at the top there, you can just barely make out the tops of the trees in the background. And so keep your eye on that as we go to this site, this slide, which is in 2015, same general area. And obviously there's been a big change. And this was in 2015. I went out in June to do the monitoring for that year. And I was really shocked to find this basically ghost marsh. That's the words I wrote down in my notebook, that this was a ghost marsh. Every single plant in an area of about 50 acres was dead at the end of June. And this was a really big surprise. So this was 3 years after restoration. There had been a slow retreat of the marsh as we had expected with introducing tidal flow and higher inundation levels. But then in 2015, there was really kind of a pretty big shift that was a bit of a surprise. And so you can imagine just kind of toggling between those two things. That's a really big impact on the food web. And Emily set out a really great framework of the importance of the food web and the importance of plants as the base of the food web, because this is really what we are trying to do, right, with restoration. We're trying to generate food for a bunch of critters that we really care about, like fish and birds. And that's what we're trying to do is increase, the approach is to restore structure so that it restores processes and thereby increases the amount of food that gets produced and access to the food for the critters that we care about. So it's really that base of the food web that is so important. So this is kind of the main message for my talk, and that's that decisions that are made in the project design phase really affect future food web productivity a lot. And this project, we learned a lot from it. I'm going to talk about the surprises, the big lessons learned. I'm not going to talk much about the monitoring, although incredible monitoring and data acquisition and analysis that went into this project by a lot of people. That's really great stuff, and you can read that in the final monitoring report, and I'll provide a link later. But I'm going to kind of talk on the things that kind of really surprised us. So, our basic conceptual model for restoration is restore structure, take the dikes out, carve some channels, unleash those natural processes, and you'll get this great productive food web back to support fish and birds and so on. And of course, nature, the lines here are not short and linear. There's actually a spaghettigram involved in each of these steps of thousands of different physical and biological interactions, feedback loops, and everything. And external pressures like climate change and non-native species and other sources of stress that cause things to go in interesting ways. And you hope that at the end you get a productive food web, and we're getting really good at restoration. So we do generally get a really productive food web. And I do want to emphasize at this point, this site is recovering and doing functioning really well as habitat. And as my talk for my talk, I'm going to really kind of focus on those surprises. So I'm going to focus on the things that we learned a lot from. So here is the Still-Squamish Estuary. The area outlined in white was the tidal marsh at the time of restoration. This project was before 𝗂𝗏 Island and before 𝗍𝗃𝗏. So this kind of indicates where the marsh was at that time. And then the restoration project was right at the mouth of the river. And because of its location there, we felt that it would have important impacts, not just on the site itself in terms of habitat development, but on some of the ecosystem scale processes. So we had objectives at both of those scales. And this is our kind of monitoring design. We had the restoration project, and then we had 5 to 8 reference sites around the entire ecosystem. And that turned out to be really important to us to understand what was actually happening on the restoration site. Because of the history of the restoration site, it's never going to match one of the reference sites, at least in the near term future, because of changes to soils and slopes and everything else. But with that suite of reference sites, we really have been able to get a much better understanding of the dynamics happening at the restoration site, as well as the potential of the restoration to affect the whole ecosystem. So we had, a couple of project objectives. One was site scale and the other was system scale to improve river marsh connectivity. And so the final monitoring report, and I'll put this at the end as well, but if you just go to 𝗂𝗏𝐶restoration.org, you can search for Fuller 2018 to find that report. So the first kind of surprise we had was that system scale objective we had of restoring freshwater delivery and sediment to the entire ecosystem. And the desire was to increase the residence time of freshwater and sediment in the system to really impact the food web, and others have talked about that as well. But this is the preliminary model, or the model that we did for the preliminary design for the project. And the warm colors are salty water and the cool colors are brackish and fresh water. And the area that supports a really productive delta marsh is that area to the right of that dark gray line. So the cool colors there support really productive marsh, and that line actually does overlap quite closely with the existing marsh. And so the model indicated that when we pull the dike out, we would greatly expand that area that would support brackish and tidal fresh marsh by taking that dike out. So the volume of water coming out of the river doesn't change, but what happens is that at high tide, the model showed that it would push the river water, the fresh water and sediment up north into the northern part of the estuary. And because of that, it effectively increased the residence time of that fresh water and the sediment in the tidal wetlands. And somebody mentioned, Emily mentioned that fire hose effect of a system that has a lot of dikes on it. And that's what we're trying to do, is kind of release the pressure on that hose that's shooting that critical fresh water and sediment way out into the bay. So this part of the project was actually the most disappointing of the project outcomes, because this did not happen. And there was a few reasons for that, I think, that contributed to that. One was that the preliminary design is, it's based on preliminary data. So the elevations we used LiDAR for that. And one thing that you find out is that LiDAR has a great accuracy when it's done against ground truth points that are on hard asphalt roads, which is where most ground truthing points are done by the vendors. But that accuracy really tails off when you have vegetation, and more importantly, when you have long, curvy, linear features like dikes, and dikes that have a lot of trees and shrubs and cattails right next to them. You can get very high error rates in the LiDAR, or a lot higher than you think you have. So the model was based on the LiDAR. And then one of the disconnects I think that happened was that in the final design phase, the project didn't go back to reevaluate the final design in the context of the assumptions that went into the preliminary design and the data that went into the preliminary design. So with the final design, you get much higher resolution data, you get ground survey points and so on that that can make your model much better if you do go back to double check that. And then another thing that happened was between the preliminary design and the final design, there was really a complete turnover in the personnel, both internal staff leading the project as well as the consultants. And so there was I think a loss of some of that institutional memory, I guess, for lack of a better word, that would have been really important, I think, for going through the system. So Nature Conservancy is working on adaptive management things right now to get through that.
Roger, you have 2 minutes.
Okay, thanks. So at the site scale, we saw fast retreat of the marsh over the first 4 years. And there were a number of reasons for that, but in 2015, it really took off in terms of the retreat of the marsh. This was much more than we expected it to happen. And I think there were a number of reasons for that. One is that, or the main reason I think, is that the site did not actually drain well for the first 2 to 3 years. And that was due to a couple of things from site history that were not incorporated into design. One was the slope. Because of farming, the slope was much more gentle on this site than any of the reference sites. Plow pan, this was mentioned in some other presentations, 1 to 2 feet or 1 to 3 feet under the soil surface, there's a hard impermeable clay layer that results from plowing. And that inhibited the development of deeper channels that would drain more quickly. The dike base, even though we took the dike all the way out, it's very, very compacted. And as a result, channels didn't carve across that like we expected. And then we did very limited channel excavation at the beginning. And others have mentioned this too, some of the older projects like this one that we wish we had done more channels. And I'm glad that projects like 𝗬𝗲𝗃 have learned from that. So that was an important thing. And then the site had really dense vegetation prior to pulling the dikes out. And when you have dense vegetation on a really gentle slope, you can trap water on the marsh plain. And so what happens is that changes the physical and chemical conditions of the soil and makes it really stressful for plants. And so we had stressed out plants, marsh retreating, and then I'm gonna skip through this one. One of the surprises was also that the projected dominant species actually never showed up, 𝗃 bulrush. And we understand that as a context of changes of its preferences are different than the other bulrushes in terms of some of the sediment qualities or the soil qualities. Soil salinity, 2015, super low river levels and super high pore water salinity. And that resulted in huge impacts to the biomass production in the site and in 2015. And that has a big impact on the food web, obviously. And then the promised killer moths, they showed up in 2015. So we had a lot of stress for 2 years, and then we got the salinity impact in the 3rd year, and that overwhelmed the plant's ability to fight off this native moth, and it wiped out 50 acres of tidal marsh. Skip through here. So key project design lessons: maintain continuity in the personnel. During the final design, make sure that you go back and check your original assumptions in the design phase. Break up those compacted dike footprints, because otherwise channels aren't going to carve across that. Excavate more channels and really adjust your scale of excavation based on site soil. So if you have things like plow pan, then you need to probably dig bigger, deeper channels to accommodate drainage. Reconfigure the topography if your slope is not going to facilitate drainage. And then control invasives post-restoration. There's a different story about narrowleaf cattail leading to some other impacts on the bulrush. So those are kind of the key design questions, I think, that came out of it. So the main message, decisions you make in design affect the future food web productivity. And I think that is it. So thanks to the funders and all the colleagues that I've worked with, and thanks to Jason and Tish and Jay for putting together a great workshop. Cheers.
Great. Thanks so much, Roger. Way to give a great talk here at the end of the morning session. Jenna, do we have any questions rolling in?
I'm not seeing any questions. I see a comment from Jay just saying great summary of the lessons learned, Roger, which I think we all agree with that.
I'll give one quick question because I've been holding my tongue and haven't asked a question all day. Roger, those moths, I know more like in Puget Sound proper, moths can be good fish food for juvenile Chinook salmon. Did you ever see them in the diets at all, or were they too big?
No, I'm not a fish person, so I have not looked at diets. I guess I've never seen them mentioned in reports on the diets of the fish. There is information on the diets, but I've never seen them mentioned other than a more general, at a higher level of taxonomy. So I don't know. They lay their eggs in the stems of the bulrushes, and then the larvae just crawl their way up, eating the inside out of the stem, and kills the stem. And it's there all the time. It's just when it appears that when there's lots of stress, they really hammer the marsh.
I've got one question over here, if we have a moment to take it, from Emily. The moths are still present in the marsh at Port Susan. Do you see them up in Padilla or elsewhere?
I have not seen them, but I haven't really looked for them. This particular group of moths attacks members of the 𝗂𝗵𝗄𝗃𝗃 family, so bulrushes and caryxes. And we don't have a lot of those in the Padilla Bay area, so I haven't seen them there.
Okay. Jason, do we have time for one more, or are we moving on?
Oh, let's do one more. It's the end of the morning.
Okay, Chelsea asks, if you could go back, is there anything you would change in the monitoring protocol to address hybridization of plant species in the estuary?
I'm sorry, did you say hybridization?
Mm-hmm. Yes.
Okay, I'm not sure what that refers to. I think, I don't know. I'm not sure what that refers to. If that's talking about the 𝗃𝗏, there's a couple of 𝗃𝗏 species, a native and a non-native one, that interact there. And that was one of the lessons I didn't spend much time on, but I think it's really important to control and have a plan to control invasives on the site. In 2016, the non-native 𝗃𝗏 really exploded as a result of some hydro issues. And in 2017, it was really big, and it had we saw another much smaller scale moth kill in the bulrush associated with plants that were with the non-native 𝗃𝗏, because the non-native 𝗃𝗏 has been shown to have allelopathic effects to bulrushes. And that was really interesting. So I'm purely speculating on that, but I think that was why we saw the second event of the moth kill.
Okay,
Great.
Thank you.
Thanks so much, Roger. Great talk. And Roger won't have as much chance to type in responses for any further questions because we'll be shutting down the Zoom, but please get a hold direct if you have more. Okay, we're in wrap up. Thank you so much to all the speakers this morning and yesterday too. It was a great 2 days and lots of great questions. So I just want to say thank you on behalf of the planning committee, and a few quick thoughts. This Zoom will be closing down. For the speakers and panelists, we'll be reconvening at 1 for smaller group discussions, and you'll have a separate Zoom link. Look for an email from Jay if you can't find that about discussions. And Tish or anyone else on the planning committee, do you have some further wrap-up comments?
I'll just echo your thanks to everyone. What an amazing couple of days. I feel like my head is just so full and spinning, and I'm making so many great connections between the talks, and it just feels really great to have been able to assemble this amazing group and then share that with everyone. So thank you all so much for coming along with us on this ride of a virtual summit and helping to make it so awesome. So we will be working with the speakers to create a proceedings. So stay tuned for that and come back next week. The embayment presentations are going to be awesome too. So we'll keep this going. Thanks so much, everybody.